Pharmacy Nigdi is exploring every avenue open to it, and the winning stride continues. A very good morning to one and all. I request dignitaries to please come on the stage. Our today's chief guest, Dr. Shyamakant Shimpi, convener of the conference, Honorable Dr. P.D. Chaudhary, organizing chairperson, Dr. Smita Pimple, organizing secretary, Dr. Vitthal Chopde, Dr. Somdatta Chaudhary, scientific committee chairman, Dr. Bhushan Pimple, head of department chemistry, Dr. Shailaja Jadhav, and Dr. Atul Phatak, head of department pharmaceutics. The galaxy of intellectuals, invited guests, dignitaries on the dais, my fellow colleagues, and dear delegates, a pleasant morning to one and all. I, Mrs. Rupali Jinturkar, Assistant Professor Pharmaceutical Chemistry Department, would like to welcome you all to the Indo-US International Conference entitled Unlocking Horizons in Global Multidisciplinary Healthcare Research, organized by Progressive Education Society's Modern College of Pharmacy Nigdi Pune in collaboration with the Association of Pharmacy Professionals. It's indeed a tremendous privilege to be standing here today to welcome you all for this inaugural function. Today, we stand at the convergence of healthcare, innovation and collaboration where disciplines converge to create solutions that have the potential to revolutionize the way we understand and address health challenges across the globe. The world of healthcare is evolving at an unprecedented pace. New technologies, methodologies, and research approaches are emerging faster than ever before, making it clear that the traditional boundaries of research must be expanded. The need for multidisciplinary approach to healthcare research has never been more urgent like today. From tackling the ongoing challenges of infectious diseases to addressing the rising tide of chronic conditions, from understanding the social determinants of health to integrating advanced technologies in medical care. These issues cannot be tackled by one discipline alone. This is where the true power of multidisciplinary healthcare research lies, in its ability to bring together diverse perspectives, knowledge, and expertise to find solutions that are not only innovative but also holistic and sustainable. Today, we will explore how the fusion of disciplines such as advanced drug delivery system, drug designing, artificial intelligence, pharmaceutical technology is vital in healthcare globally. I feel privileged to welcome all the dignitaries on the dais and the chief patron of the event, Honorable Dr. G.R. Ekbote Sir, Chairman, Business Council, Progressive Education Society, who has joined the event through online mode. Please have a big round of applause for the conference. Modern College of Pharmacy is a part of Progressive Education Society, which is imparting education since 1935. Being a chairman of Progressive Education Society, Honorable Dr. G.R. Ekbote Sir has always inspired, supported and guided us for organizing such scientific events. Other patrons of the event are Professor S.S. Deshmukh, Secretary PE Society, Professor Jyoti Ekbote, Joint Secretary, Professor Suresh Todkar, Joint Secretary, Dr. Nivedita Ekbote, Deputy Secretary, Professor Suhasini Itkar, Visitor, Modern College of Pharmacy, Nigdi, Pune. Today, for inaugural function, we feel honored to have on stage Dr. Shyamakant Shimpi, Senior Vice President and Head R&D, Center Pharmaceuticals Limited, Pune, India, as a chief guest. Thank you so much, sir. Your presence has truly uplifted the event. A man of distinct vision, the polar star of the institute and convener of this conference, Honorable Dr. P.D. Chaudhary, Principal, Modern College of Pharmacy, Nigdi. The vibrant and resilient organizing chairperson, Dr. Smita Pimple, Professor, Department of Pharmaceutics, An inspiring personality and organizing secretary, Dr. Vittal Chopde, Professor, Department of Pharmaceutical Chemistry. Young and dynamic organizing secretary, Dr. Somdatta Chaudhary, Associate Professor, Department of Pharmaceutical Chemistry. The guiding light and scientific committee chairman, Dr. Bhushan Pimple, Professor and Head, Department of Pharmacognosy. The strong pillars of MCOP, Dr. Shailaja Jadhav, Professor and Head, Department of Pharmaceutical Chemistry, and Dr. Atul Phatak, Professor and Head, Department of Pharmaceutics. Now let us proceed the inaugural function with the blessings of Goddess Saraswati. I request all the dignitaries on the dais to please proceed for lamp lighting ceremony.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकरा या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापहा शुक्लां ब्रह्मविचारसारपरमाम् आद्यां जगद्व्यापिनीं वीणापुस्तकधारिणीमभयदां जाड्यान्धकारापहाम्
Thank you so much. Now I request the convener of conference, Dr. P.D. Chaudhary, to deliver the welcome address.
Honorable Dr. J.R. Ekbote Sir, Chief Patron and Chairman, Business Council, PE Society Pune. Honorable Chief Guest, Dr. Shyamkant Shimpi, Senior Vice President, Research and Development Center, Pharmaceuticals. Dr. Smita Pimpre, Organizing Chairperson. Dr. Shailaja Jadhav, Dr. Atul Phatak, HODs of respective Department of Modern College of Pharmacy. Dr. Vittal Chopde, Dr. Somdatta Chaudhary, Organizing Secretaries of this International Conference, Dr. Bhushan Pimple, Chairman Scientific Session of this International Conference, dignitaries of the dais, speakers, distinguished delegates, esteemed guests, and dear colleagues. Very good morning to one and all. It's my absolute pleasure and privilege to welcome you all to the Indo-US International Conference on Unlocking Horizons in Global Multidisciplinary Healthcare Research, organized by Progressive Education Society's Modern College of Pharmacy, Nigadi, Pune, in collaboration with Association of Pharmacy Professionals. As the convener of this prestigious event, I am truly honored to see such a remarkable gathering of the scholars, researchers, and the professionals from across the globe, all united by the shared passion for global multidisciplinary healthcare research. We are privileged to have with us today our chief guest, Dr. Shyamkant Shimpi, Senior Vice President, R&D Center Pharmaceuticals, a renowned experts in pharmaceutical research and development, who will share his insights during his keynote address. Our conference theme Unlocking the Horizons in Global Multidisciplinary Healthcare Research reflects our collective commitment to explore the cutting edge technologies that address the global challenges. Over the next 3 days, we will delve into topic ranging from NDDS, artificial intelligence, molecular docking, network pharmacology, etc. etc. Friends, I am delighted to welcome you to explore the exceptional academic and research opportunities at Modern College of Pharmacy, established in 1998 by the Progressive Education Society in the bustling industrial area of Pimpri Chinchwad. Ours is the premier institution recognized for its excellence in pharmaceutical education and research, approved by Government of Maharashtra, AICT, Pharmacy Council of India, and the college boasts a permanent affiliations with Savitribai Phule Pune University, an accreditation by NBA and NAC with an impressive A plus grade and with a CGPA of 3.47. College offers a wide range of programs including B.Pharm, M.Pharm, C in different disciplines, PharmD post-baccalaureate, and more prestigious, the college is approved research center for PhD and doctoral research by Savitribai Phule Pune University. Notably, it has been consistently ranked with the top 100 colleges in the NIRF pharmacy category for the past 6 years and consecutively received a platinum rank by CII survey for the last 5 years. In 2015-16, it was named the best college in the professional colleges category by Savitribai Phule Pune University. Recently, the college has proudly embraced an autonomous status granted by UGC and further enhancing its educational offering and standings. In the last IRF ranking of health sciences, we achieved a national rank of 63 and 64 consecutively for last 2 years, which affirms its position as a leader in pharmaceutical education. This conference serves as a dynamic platform for the exchange of ideas, the presentation of groundbreaking research, and the fostering of collaboration that transcend the borders. The theme of this year's conference, Unlocking Horizons in Global Multidisciplinary Healthcare Research, reflects our commitment to address the most pressing challenges and explore the innovative solution in our field. Over the next 3 days, we will hear from the distinguished speakers, engage in thought-provoking discussions, and witness the presentations on pioneering research that has the potential to shape the future of our research scholars and the researcher. I encourage each one of you to actively participate, share your insight, and forge a new connection that will lead to the fruitful collaboration and drive the innovations. I extend my heartfelt gratitude to our esteemed speakers, panelists, sponsors, scientific partners, and organizing committee whose relentless efforts have made this event possible. A special thank to all our attendees. Your presence is what makes this conference truly meaningful. I would like to extend my sincere thanks to our management, especially Dr. G.R. Ekbote sir, for his constant support and guidance in organizing such a wonderful events. With that, I officially declare that this Indo-US International Conference on Unlocking Horizons in Global Multidisciplinary Healthcare Research is now open. I am looking forward to an inspiring and enriching experience for all of us. So thank you so much, and once again I welcome you all. Thank you.
Thank you so much, sir. Now I request organizing chairperson Dr. Smita Pimple to enlighten the insights of conference.
Very good morning to one and all. The esteemed dignitaries over here, Honorable Chief Guest of the inaugural function, Dr. Shamkant Shimpi Sir, Senior Vice President R&D, Center of Pharmaceuticals, Honorable Chief Patron, Professor Dr. G.R. Igbute Sir, Chairman Business Council of Progressive Education Society, Pune, Convener Dr. P.D. Chaudhary Sir, Principal Modern College of Pharmacy, Nigri, Dr. Vitthal Chopde Sir and Dr. Somdatta Chaudhary Sir, Organizing Secretaries, Dr. Bhushan Pimpre, Head Scientific Committee, HOD Pharmacognosy Department, Dr. Shailaja Jadhav Ma'am, HOD Pharmaceutical Chemistry Department, Dr. Atul Pathak Sir, HOD Pharmaceutics Department, dignitaries, please accept my sincere regards. I extend a warm welcome to all the enthusiastic faces in the audience. It is with immense pleasure I stand here to present the insights and ideas behind conceptualizing the theme of this Indo-US International Conference on Unlocking Horizons in Global Multidisciplinary Healthcare Research. Though Rupali ma'am has already given the introduction, but I suppose since 2019, after the outbreak of devastating pandemic corona to today's date, we all have heard about GBS, Guillain-Barré syndrome. The fear of survival is creeping in common people's mind. But we, as healthcare professionals, have a huge responsibility to face and to tackle any challenges which may come our way. In conclusion, the healthcare landscape is undergoing a very rapid transformation driven by emerging diseases, evolving health systems, and the increasing demand for sustainable solutions. To address these dynamic challenges, advancement in technology starts at drug design level. Not always we might have long timelines for the drug discovery as well as for converting these new drug molecules into the palatable drug delivery system. So we have come up with tools like in silico studies, AI generated QSAR studies, several softwares in optimization of drug delivery systems, IV/IVC tools, and we expect a paradigm shift when the conventional healthcare system will be completely replaced by the personalized medicine system, which is also referred as prescription medicine or precision medicine. So, redefining this approach in treating the patients, soon we will be shifting over to personalized medicine system. The objective behind the theme of conference that we adopted is to underscore the importance of innovation, resilience and adaptability in tackling these multifaceted global challenges in the healthcare research. But one common factor which underlines almost all technical advancements is AI, that is artificial intelligence. We all have sound minds to realize this fact that as much as AI could be a blessing, it could also be a curse if not used thoughtfully, morally and ethically. It could even be a threat to the well-being of mankind, so judicious use of AI is the prime responsibility which should be borne by all of us. Through this platform, I would like to make an earnest request to all academicians that while you transfer your knowledge about all advancement, please make sure that you are also making your disciples aware about the responsibility component. This conference is brainchild of our mentor, Dr. P.D. Chaudhary Sir, and later many other colleagues of mine have contributed to this final form of Indo-US International Conference. The cooperation and support by APP, the Association of Pharmacy Professionals, needs a special mention here. Without their inputs, we couldn't have made it this grand. We feel fortunate enough that today we have with us Dr. Shamkant Shimpi Sir as chief guest. I seek his best wishes for our event. This conference is in hybrid mode, keeping in mind that it should reach to the needy and budding researchers without any difficulty. And I feel elated to state that we got an overwhelming response. In all, we have received 410 registrations, which is really an encouraging number. I thank all the participants from the bottom of my heart. Now coming to the summary of conference schedule. Today, the first day, we will be having 2 technical talks in scientific session. Immediately after inaugural function, we are listening to a renowned personality, Professor Dr. Javed Ali, Head Department of Pharmaceutics, School of Pharmacy Education and Research, Jamia Hamdard, Delhi. He will be presenting on strategic approach for the delivery of drugs for the treatment of breast cancer. This session will be chaired by Honorable Dr. B.S. Kuchikar sir, and Dr. Vikram Gharge sir would be the co-chairman for the session. Second talk will be delivered by Dr. Vijay Masand, Professor Department of Chemistry, Vidya Bharati Mahavidyalaya, Amravati, on AI and QSAR in the drug design and discovery. We will have Dr. Satish Pardeshi sir as chairman and Dr. Sachin Agavne sir as co-chairman. In the post-lunch session, we are having poster and oral presentations running simultaneously, followed by a short and sweet cultural program. Please do not miss it. Then second day onwards, all our sessions will be conducted in online mode. We will be having talks delivered by international speakers. The day will begin with a welcome speech delivered by Dr. Rajiv Dahiya sir. He is founder president of the Association of Pharmacy Professionals. Presently, he is professor at School of Pharmacy, Faculty of Medical Sciences, University of West Indies, St. Augustine, Trinidad, Tobago. This will be followed by a speech by Dr. Simone Faye Walcott, Vice President, APP, West Indies International Branch. She is from Department of Chemistry and belongs to the same institute as Dr. Rajiv Dahiya. Conference remarks will be presented by Dr. Alekh Dash, President, APP American International Branch, Associate Dean, and Professor, Department of Pharmacy Sciences, School of Pharmacy and Health Professions, Creighton University, Omaha, Nebraska, USA. Later, from the same institute, Dr. Somnath Singh, International Head APP and Professor, will be with us to deliver a talk on leveraging collaborations for out-of-box research. For this session, we will have Dr. P. Shanmugasundaram as chairman and Dr. Mehul Patel as co-chairman. Second technical talk on Smart Pharma, exploring the intersection of AI and innovation, will be presented by Dr. Gaurav Gupta, President APP Gulf International Branch, and he is Adjunct Research Professor, Center of Medical and Bio-Allied Health Science Research, Ajman University, Ajman, UAE. Dr. Saurabh Dahiya sir will be chairing this session and Dr. Jyoti Srivastava will be present as co-chairman. Following this, closing remarks will be presented by Dr. Vetriselvan Subramanian, Vice President APP, Malaysian International Branch. He is Professor at Department of Medical Sciences, School of Medical and Life Sciences, Sunway University, Malaysia. Remaining day has been reserved for the online poster and oral presentations, where industrial persons will be with us as chairman to assess the presentations by participants. On last day, that is 12th March, online oral and poster presentations will continue, and then we will be listening to Dr. Arabindo Ghosh, Assistant Professor, Department of Molecular Biology and Bioinformatics, Tripura University. We will be having with us Dr. Sunil Jalalpure sir as chairman and Dr. Parshuraman as co-chairman for this session. Valedictory function and award declaration will follow. We did plan very meticulously and crafted this conference. We as a whole organizing team has put our heart and soul in every aspect of this event. I hope you will find the next 3 days very informative, but at the same time enjoyable too. I pray to God and wish me and my team for the smooth running and success of this conference. Once again, thank you for coming over here and joining us today. Thank you so much.
Thank you so much, ma'am. We feel privileged to have Dr. Shyamkant Shimpi, Senior Vice President and Head R&D Center Pharmaceuticals Limited, as our chief guest. I would like to give his introduction in short. Dr. Shyamkant Shimpi is a distinguished pharmaceutical scientist with over 22 years of research and development experience. He currently serves as Senior Vice President and Head R&D at Center Pharmaceuticals Pune, where he leads a team of over 100 formulation analytical team, also handling around 40 plus projects at various stages. Prior to Center Pharmaceuticals, he has worked in many entrenched industries that include Aurobindo Pharma Limited Hyderabad, IPCA Laboratories Limited Mumbai, Sai Life Sciences Pharma Limited Pune, and RPG Life Sciences Mumbai. Talking about his academic brilliance, Dr. Shimpi holds a PhD in pharmaceutics from Pune College of Pharmacy, M.Pharm from Birla Institute of Technology Ranchi, and B.Pharm from Pune University. His expertise spans new product and process development, technology transfer for commercialization, bioequivalence studies, and regulatory filings for global markets, includes USA, Europe, stabilization and solubilization techniques, bioequivalence strategies in new dosage form, design and product development, and many more. He is recipient of prestigious grants and fellowships from various national and international firms. He has contributed extensively to pharmaceutical innovation, holding multiple patents and authorizing numerous international publications. He is also a reviewer for reputed scientific journals comprising elsewhere and has guided postgraduate and doctoral students in pharmaceutical sciences. With his deep scientific acumen and leadership, Dr. Shimpi continues to drive advancements in pharmaceutical research and development. I request Convener and Principal Dr. P.D. Chaudhary to felicitate the Chief Guest with memento, certificate and floral bouquet as a token of respect and admiration. Please have a big round of applause. Thank you so much. I would like to give an introduction of Chief Patron of the event, Honorable Dr. G.R. Ekbote Sir, an Emeritus Professor of Surgery, BJ Medical College, Pune. Dr. Gajanan Ekbote is a distinguished academician, surgeon and administrator with over 42 years of experience in medical education and healthcare. He has made significant contributions to medical research, policy making and higher education governance in India. Key positions held by him are ex-professor of surgery, BJ Medical College, Pune, ex-pro vice chancellor, Maharashtra University of Health Sciences, Nasik, ex-dean Faculty of Medicine, University of Pune, member Senate, Maharashtra University of Health Sciences, Nasik, ex-member Board of Governors, National Institute of Technology, Surathkal, ex-member Academic Council UGC nominee, West Bengal University of Healthcare Sciences, Kolkata, ex-member Planning Commission Steering Committee of Higher and Technical Education and Teachers Education, Government of India, ex-member Management Council, Savitribai Phule Pune University and MUHS University. He has excelled in academic qualifications with MBBS and MS in General Surgery from BJ Medical College, Pune, and member National Academy of Medical Sciences. Also PhD equivalence in General Surgery from Maharashtra University of Health Sciences, Nasik. Talking about his academic and professional achievement, Sir has guided over 50 students for their MS in General Surgery degrees. He has been shortlisted thrice for the Vice Chancellor post at MUHS Nasik and shortlisted for the Vice Chancellor post at Savitribai Phule Pune University. Granted PhD equivalence by MUHS for outstanding academic contributions. Published more than 80 research articles in various national international journals. Special invitee for framing UG PG regulations at Medical Council of India. Recently, Professor Dr. G.R. Ekbote Sir is invited as an expert member by committee constituted for suggesting modifications in Maharashtra Health Sciences Universities Act 1998. He has been honored with many prestigious awards, including Lok Shahir Anna Bhausathe Puraskar at the hands of Honorable Shri Eknath Ji Khadse. MACCIA Award was given at the hands of Honorable Shri Sharat Chandra Ji Pawar. Vocational Excellence Award at the hands of Honorable Shri Girish Bapat, Minister for Food, Civil Supplies and Consumer Protection Department, Maharashtra State. Punya Gaurav Puraskar was given at the hands of Honorable Padma Vibhushan Dr. K.H. Sancheti, eminent orthopedic surgeon in India, Best Teacher Award, and many more. Sir has enormously contributed to most prestigious Progressive Education Society. Dr. Ekbote Sir is a chairman, Progressive Education Society Pune, leading 62 institutions with 52,000 plus students. Progressive Education Society is a reputed educational corporate body in the state of Maharashtra, which is working in the field of education for last 88 years. The steady growth of PE Society symbolizes the rise of Dr. G.R. Ekbote as a member of the Business Council in the year 1986 to Joint Secretary in the year 1992, further as a chairman from the year 1994 onwards till today. Instrumental in policy development for self-financing universities in Maharashtra and active participant in National Education Policy 2020 discussions. Dr. Ekbote Sir's commitment to academic excellence, medical research and progressive education has made a lasting impact on the healthcare and education sectors in India. We are truly blessed to have him here for this scientific event. Today, although he could not come here, but he will be always there to support us. As he has joined us today through the online mode, I request him to accept the felicitation virtually on behalf of Convener and Principal Dr. P.D. Chaudhary. Before we move ahead, I request Souvenir Committee to please come on the stage. Dear delegates, to help you remember this conference and the meaningful connections made, we are thrilled to present a special souvenir. This souvenir is more than just a token. It's a symbol of collaboration, innovation, and testament of the knowledge that we strive to advance every day. I request all the dignitaries on the dais to unveil the souvenir. I would like to specially extend an appreciation to Souvenir Committee members, Dr. Bhushan Pimpe, Dr. Mohini Kucheka, Mrs. Suvarna Varze, Dr. Anjali Kumbhar, and Dr. Rohini Chavan for continuously and meticulously striving to get this souvenir ready in short period of time. Please have a big round of applause for the scientific committee for their efforts. Thank you so much. I would like to inform delegates that the soft copy of this souvenir will be shared to all the delegates through mail on their registered email IDs soon. Now I request the chief guest of today's function, Dr. Shyamakant Shimpi, to address the gathering.
Good morning to everyone and welcome to wonderful conference, scientific conference. Thank you for the nice introduction. I am honored and happy to attend this scientific conference. Today's event promises a scientific session with the expert on the recent development in research. In a recent era, in relevance to the theme of this conference, I will give a short two examples of the recent development in the research area. AI has made a significant contribution in the research area. I will take a current example of nitrosamine impurities, where most of the pharmaceutical industries are struggling to stabilize the product. These impurities are carcinogenic in nature. But with the help of nitrosation data generated over the years, uh, the scientist has developed the QSR models to predict the formation of these impurities, and the scientists can save a lot of traditional research time in this field. The another example on the AI based drug discovery. So recently the Hong Kong based company has developed a molecule with AI, which is already completed the clinical phase 1 studies and entered into the clinical phase 2 studies. What this means is, this is the scientists can save the time of almost 10 years and money around 1.9 billion euros, which is required for the traditional drug discovery. As we all knows that there is lot of efforts needed for the drug discovery, which is in the past it was traditional way, but now with the help of AI we can shorten the time and develop the new molecules, which will also helps to reduce the cost of the product and make the medicine affordable. We are fortunate to have knowledgeable and experienced professional in pharma field to speak to us today. Let us take advantage of this opportunity. We have an exciting topic lined up, so I will not take much time. I would like to thank you, organizing committee, for this wonderful scientific international conference. Thanks to Modern College of Pharmacy, management, staff, students, and Association of Pharmacy Professionals. And special thanks to Principal P.T. Chaudhary sir for inviting me and giving me opportunity for this conference. Thank you. Thank you very much.
Thank you so much, sir. Now I request our Chief Patron, Honorable Dr. G.R. Ekbote sir, to enlighten us with his valuable words through presidential speech. He is available through online mode.
Dignitaries on the dais and of the dais. It is with great honor and deep sense of responsibility that I myself present you on online mode at this significant juncture in healthcare and pharmaceutical research. As the chairman of Business Council of Progress to Education Society, I extend a warm welcome to all of you gathered here and online for the Indo-US International Conference. Firstly, I would like to express my gratitude to our co-organizers, esteemed collaborators, with whose support we have been instrumental in bringing this international conference to life. Their dedication and their devotion had made it possible to organize international conference on unlocking horizons in global multidisciplinary healthcare research. This conference aims to integrate artificial intelligence and other advanced technologies in drug design and healthcare, covering topics like artificial intelligence, i-QSAR, drug design, strategic approaches for drug delivery in breast cancer treatment, and leveraging collaboration for out-of-the-box research. Progress to Education Society is a very reputed educational trust in the state of Maharashtra, which was founded in 1934 by late Shankarji Kanitkar along with 4 of his teacher colleagues. This trust was founded by teachers only. We are fortunate to have Modern College of Pharmacy, where which is an example of innovation, and it is recognized nationally for excellence in pharmaceutical education and research. Through such platforms like international conference, we nurture the minds of will pioneer the next waves of medical breakthroughs. This conference makes a critical point in an ongoing journey of discovery and innovation. The challenges faced in healthcare today demand a collaborative interdisciplinary approach. It is only through such synergy that we can aspire to unravel complex scientific puzzles and transform the future of medicine. Although I belong to medical faculty, I was professor of surgery in Vijay Medical College, Pune. I have little knowledge of the pharmacy faculty because the pharmacy faculty was once upon a time a part and parcel of medical faculty in the University of Pune. I think the organizers I will suggest they should have kept one topic on what is the ongoing research and ongoing things, advances in medical faculty, because it is a part of healthcare system also. So just within 5 minutes I will elaborate you what are the different things, advances going on the medical faculty or medicine. Number one, there has been a lot of research and advances in the insulin delivery system regarding the diabetic patients. Days and days, we see a lot of improvement in the survival of the diabetic patients. We have got the different drugs, they are available for diabetes, different insulins, they are available for diabetes, and now we have come to a stage where only once a month insulin is required to control the diabetes mellitus. So that is the most important advance which is taking place in the management of diabetes. People were not knowing what is the exact pathogenesis and what are the different pathogenesis and manifestations of different complications of diabetes mellitus. Because I remember reading the biography of Lokmanya Tilak ji, he was suffering from diabetes, and 1920, when he expired, before that, he started eating a lot of ghee because it was supposed that this ghee will definitely benefit in the management of diabetes. Although that was a very wrong concept at that time. So there has been many more advances in the management of diabetes. Secondly, about radiotherapy for cancer diseases, new therapy mechanism has come in the form of cyber line, where it is a just precise radiotherapy given that to that part of the body which is affected by the cancer. So the complications because of damage to other adjacent organs, they are very much prevented by cybernetic radiotherapy, which is very available in Pune, in Ruby Hall, and it is available in Chennai and Bangalore only. Only 3 cities cybernetic radiotherapy is available, and that is a very good, showing very good response in the management of the radiotherapy. Thirdly, when we were students, there was hardly any advance in the management of liver cirrhosis or chronic kidney diseases. Now there has been a lot of response and advances in liver transplants, kidney transplants. Now the survival rate after liver transplant is almost 95% at good centers, and for the kidney transplant it is the same at very good centers. There are a lot of new immunosuppressive drugs which are available, which make life of the transplant in the post-transplant period very simple and very easy. That management has very simpler after the discovery of these new immunosuppressive drugs. Previously, the results of heart transplant, the liver transplant, were just 5%. Now there is also 70 to 80% survival rate of the heart transplant in many urban cities like Chennai, Pune, Mumbai, Delhi, Bangalore, etc. Lastly, I would say that there have been much advances using the artificial intelligence in the Department of Surgery and the Department of Orthopedics. We are performing the surgery, because basically I am a surgeon, with the use of robotics. So robotic surgery is very precise, with very less complication in the post-operative period, and the patient can be discharged within few days, 3 to 4 days after major surgery, like colonic resection, the small bowel resection, thyroid surgery, breast, simple mastectomy for the breast cancer patient, etc. So there has been a lot of advances. I cannot narrate this in medicine. I cannot narrate in just 5 minutes. But I can suggest the organizers, if you have got time, I can have one good session on what are the different advances and researches they are going on in the field of medicine. I extend all the thanks to Professor P.D. Chaudhary and his dynamic and vibrant team for organizing a very good international conference on such a very important subject at this junction. I extend all again the warm welcome to all the dignitaries, including Professor Shimpi, who is chairing this session. I thank you very much to all of you and wish the conference all the best during the ongoing 3 days. Thank you very much. All the best for your conference.
Thank you so much, sir, for enlightening us about the recent advances in healthcare. Now I request Organizing Secretary Dr. Somdat Chaudhary to propose vote of thanks.
Dear esteemed innovators, visionaries, and healthcare pioneers, good morning to all of you. And it's my great privilege to give a vote of thanks for the inaugural function. Today we gather here not just on the cusp of enriching the learning experience, but to forge a new path in the landscape of a global multidisciplinary healthcare research. So, with the immense gratitude and excitement, I extend a heartfelt vote of thanks to all of you who brings this event for the life. First and foremost, I would like to express our profound gratitude to our Chief Patron, Dr. G.R. Egbote, Chairman of a Business Council PE Society, for his invaluable support and the guidance. Your vision and commitment to excellence inspire us a lot. Definitely, we will implement the suggestion made from you, sir. I special thank you for our esteemed patrons, Secretary Professor S.H. Deshmukh, Joint Secretary Josna Egbote, Joint Secretary Professor Suresh Todkar, DY Secretary Dr. Nivedita Egbote, and Visitor Professor Suhasini Itkar. Your continued patronage is a cornerstone for our success. On behalf of everyone, I extend a warm welcome to heartfelt thank to Mr. Shamkan Shimpi sir, Vice President of the Center Private Limited, for joining us as a chief guest despite your busy schedule. Your presence and insight greatly enriched this inaugural function, strengthening the bond between the academia and industry. Thank you, sir, for your invaluable support and contribution. I extend heartfelt thank you to our scientific partners and collaborators, including Calidus Research Laboratory Private Limited, IPIS Intellectual Property Intellect Services, Elite Institute of Pharmaceutical, Aster Analytics, Anasin Lab Private Limited, ERA Consultancy and Research Organization, VM EduLife Solution, Passiflora Laboratories, PASI Patent Administrative Services Private Limited, Emprex Nutraceuticals, Pegasus Clinicare, Royal Academy of Career Excellence, MAGS Research and Training Private Limited, Crystal Biosolutions, and Insensia Health Clinic. So your support and collaboration enhances our ability to explore and innovate within the field and significantly contribute to our ranking and recognition in the IIRF each year, helping us maintain our stature as a leader in the pharmacy education. As we eagerly await the valuable insight and contribution from our distinguished speakers, I would like to extend our sincere gratitude in advance to Dr. Javed Ali, Dr. Vijay Masand, Dr. Somnath Singh, Dr. Gaurav Gupta, and Dr. Arvind Ghosh for accepting our invitation to speak at this conference. Your expertise and willingness to share your knowledge not only enrich our event but also inspire and enlighten all attendees. We are profoundly thankful for your participation and look forward to your presentations. Before we proceed with our enriching sessions, I want to express our anticipation and gratitude toward our distinguished chairmen and co-chairmen for the scientific sessions. I express special thanks to Dr. Kuchekar, Dr. Pardeshi, Dr. Shanmukh Sundaram, Dr. Dahiya, and Dr. Jalalpure for leading our session. We are also grateful to our co-chairmen for the scientific session, Dr. Garge, Dr. Agavne, Dr. Patel, Dr. Srivastava, and Dr. Parshuraman for your forthcoming contributions. Your expertise will undoubtedly enhance our understanding and drive the success of this conference. A heartfelt thank you to the Association of Pharmacy Professionals for their contribution and support for bringing this conference for the fruition. The key members of APP include Dr. Rajiv Dahiya, who serves as a founder president, Dr. Sunita Dahiya, who is a organizing chairman, and General Secretary, Professor Dr. Alka Agarwal, who is a convener for this APP. So these members play significant roles in both their respective academic institution and with the APP contributing to the organization's missions to serve the pharmacy professionals dynamically across various sectors, including education, research, and industry involvement. Your partnership is invaluable for us. As we anticipate the engaging and insightful oral and poster presentation at our upcoming conference, I would like to extend our heartfelt gratitude to our evaluators whose contributions are vital. Your expertise and discerning judgment are invaluable as we strive to showcase and nurture the most innovative ideas and research in our field. We deeply appreciate your commitment to upholding the high standard of scientific disclosure and providing essential feedback to all the participants who have from various sectors of this industry. Thank you so much for your dedication. Our sincere appreciation also goes to the delegate who are the essence of this conference. Thank you so much for your enthusiastic participation and bringing diverse perspective to our discussions. On behalf of our organization, I extend heartfelt thank you to all to who have contributed on the ongoing success of this event. I must mention our deep appreciation to our convener, Dr. P.D. Chaudhary, then chairperson, Dr. Smita Pimple, Dr. Vittal Chopde, who is one of the organizing secretary and other LOC members, and dear all colleagues and our non-teaching staff members, those who are working in the background, whose names are impossible to take here because of time constraints. Your hard work, restlessness, effort, and dedication are greatly appreciated. I appreciate everyone's contribution to this event. We will share a detailed vote of thanks at the conclusion of this event to further acknowledge your efforts. Thank you everyone for making this event successful thus far. I cannot enough the staff of Gadi Madgulkar Auditorium, those managing the online platform. Your streamless services enable this hybrid mode of conference to proceed smoothly. In conclusion, let us move forward into the scientific session with the spirit of inquiry and collaboration. Thank you everyone once again for being a part of this inaugural function. Let's make this conference a memorable and productive one. Thank you so much.
Thank you so much, sir. As we have come to an end of inaugural function, I request everyone to please stand at your own place for national anthem.
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य शुभ नामे जागे, तब शुभ आशीष मांगे, गाहे तब जय गाथा, जन गण मंगल दायक जय हे भारत भाग्य विधाता, जय हे जय हे जय हे, जय 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 हे। भारत माता की
Inaugural function has been brought to an end. We will now start with the scientific sessions. I request Principal Dr. P.D. Chaudhary to escort the dignitaries of the dais. As we embark on this journey, I encourage each one of you to think beyond the confines of your discipline, to be open to new ideas and to engage in meaningful discussions that can lead to breakthroughs in global healthcare. Let us unlock the full potential of multidisciplinary collaboration as we work together to shape a healthier, more resilient world for all. First scientific session will be conducted by Dr. Javed Ali sir. He will give a scientific talk on strategic approach for delivery of drugs for the treatment of breast cancer. This scientific session will be graced by the chairman of the session, Dr. B.S. Kuchekar sir, senior professor and advisor, former dean, Dr. Vishwanath Karad, MIT World Peace University School, Pune, and co-chairman, Dr. Vikram Gharge, Director R&D Formulations, MQ Pharmaceuticals Limited, Pune. I request Speaker Dr. Javed Ali, Chairman Dr. B.S. Kuchekar and Co-Chairman Dr. Vikram Gharge to please come up on the stage and have a seat. I am honored to introduce co-chairman of the session, Dr. Vikram Gharge, a distinguished leader in pharmaceutical research and development. With over 24 years of experience, he has made remarkable contributions to formulation, analytical research, regulatory strategy, and intellectual property. Currently serving as Director of Research and Development, MQ Pharmaceuticals Limited, Pune, Dr. Gharge is known for his innovative approach, problem-solving expertise, and strategic leadership in the pharmaceutical industry. He has played a key role in product development, process optimization, and market expansion, ensuring successful commercialization with scientific excellence and business efficiency. Dr. Gharge has led initiative in business process improvement, reverse engineering, and complex dosage form development. His expertise spans first to file strategies, bioequivalence studies, and technology transfer, making him a pivotal force in pharmaceutical advancements. Academically, Dr. Gharge holds a PhD in pharmaceutics and has demonstrated his research acumen through 5 patents, 20 publications, and a book. His dedication to mentoring and organizational growth has been instrumental in shaping the future of pharmaceutical research. It is a privilege to welcome Dr. Vikram Gharge sir, a visionary in the field of pharmaceutical innovation. I request you, sir, to please introduce Chairman of the session, Dr. B.S. Kuchekar.
Good morning, everybody. We are honored to introduce Dr. B.S. Kuchekar sir, an eminent academician, researcher, and mentor in the field of pharmaceutical science. With an illustrations career of 45 years, Dr. Kuchekar sir has significantly contributed pharmaceutical education, research, and intellectual property rights. Sir has held multiple prestigious qualifications including B.Pharm, M.Pharm, Gold Medalist, PhD, LLB, Postgraduate Diploma in Law. He has worked prestigious institutes, academicians as a Pune College of Pharmacy, Government College of Pharmacy, Karad, Aurangabad, and Amravati since 2008. He has associated with MIT World Peace University Pune, where he has served Principal, Dean of Faculty of Pharmacy and Students Affairs, and currently as an advisor, School of Health Science and Technology. A professional researcher, Dr. Kuchekar has 3 patents, 4 books, and 179 peer-reviewed research publications to his credit. He has successfully guided over 100 postgraduate and 16 PhD scholars, shaping the next generation of pharmaceutical scientists. He has delivered over 155 lectures and a critical topic like analytical research, IPR, patent filing, pharma litigations, and accreditations process at national and international forums. His leadership extends beyond academia. He is director of BS Council of Education and Research, a non-profit organization dedicated to support economically weaker yet talented students. Dr. Kuchekar has life members of several estimated professional bodies like IPA, ISTE, ISCPT, APTI, and American Society of Science. He has honored with Chartered Chemist title by the Institute of Chemists, India, and is a fellow of Royal Society of Chemistry, London. Sir has played a key roles in policy making and academic governance, serving as a Senate member of Savitribai Phule University, Pune, a member of various universities like AICTE, DTE, NAC, MPSC committee. His outstanding contributions have been recognized with numerous prestigious awards like Lifetime Achievement Award by IPA, Healthcare Leadership Award by World Health Organizations and Wellness Congress, a Golden Educationalist of India Award 2013, National and International Forum, New Delhi, a Fellow of Royal Society of Chemistry, London, Principal of Year Award by APTI, and Best Principal Award by SPPU, and many more. Sir has a leadership, dedications, educations, and pioneer research continue to inspire to the pharmaceutical committee. It's a privilege to welcome such distinguished personality. Thank you.
Thank you so much, sir. Now I request Chairman of the session, Dr. B.S. Kuchekar, sir, to introduce Speaker of the session, Dr. Javed Ali.
Good morning. Let me take the opportunity to introduce the Speaker of Scientific Session number 1, Dr. Javed Ali. Namaste, sir. Dr. Javed Ali is a renowned academic and leader in pharmaceutical sciences, currently serving as a professor and head Department of Pharmaceutics at the School of Pharmaceutical Education and Research, Jamia Hamdard, New Delhi. With 28 years of experience, he also leads the Intellectual Property Management Cell at the same institution. Dr. Ali has an impressive academic record, having earned gold medals in both his B.Pharm and M.Pharm from Jamia Hamdard, followed by PhD from the same institution. He furthered his expertise as a postdoctoral fellow at the University of Frankfurt, Germany. As a pioneer in drug delivery research, his work focuses on enhancing oral bioavailability and nanoparticulate drug delivery for CNS disorders. He has authored over 360 research papers, several books, and has guided 96 M.Pharm and 52 PhD scholars, holding 5 Indian patents to his credit. His contributions have gained global recognition, reflected in his H-index of 85 and over 28,500 citations of Google Scholar. He is also listed among Stanford University's world's top 2% scientists and has received prestigious awards including National Technical Teachers Award from AICTE, Distinguished Scientist Fellowship from King Saud University, Saudi Arabia, with the grant of 1,25,000 US dollars, the INSA Teacher Award, UGC Research Award, Voicecast Fellowship, GST, and many, many more. Beyond academia, Dr. Ali actively participates in policy making and serves on various committees including PCI, AICTE, NBA, NAC, NTA, DRDO, Bureau of Indian Standards, and many more. He is also on the editorial board of reputed leading journals, research journals. Professor Ali's dedication to education, research, and scientific innovation makes him a significant figure in the field of pharmaceutical community, inspiring many students and professionals globally. With this, I request Professor Javed Ali to take the charge of the session and please talk on the very important topic, strategic approach for delivery of drugs for the treatment of breast cancer. Professor Javed Ali here. Thank you.
A very warm good morning to all of you. Namaskar to all of you. At the outset, I would like to thank the chairman of the session, Dr. Pritekar, for introducing me in detail. I would like to thank a very eminent academician, my friend, Dr. Chaudharyji, for inviting me, and the organizing committee as well, who have invited me for interacting with you all. As mentioned already in the program, right, I will talk about the strategic approach for delivery of drugs for the treatment of breast cancer. The work is an outcome of an i-QSAR grant, and accordingly, I'm going to present that. Right. Next slide, please. So, before starting the actually scientific content of the presentation, I would just give you a brief outlay of the institution where I'm working. I'm working at School of Pharmaceutical Education Research, Jamia Hamdard. The institute was earlier known as Hamdard College of Pharmacy. It was an affiliated college to Delhi University in 1972, and the B.Pharm course started in 1973, followed by the first M.Pharm course in pharmacognosy in 1982, and then by Act of Parliament, the institute was converted into a dean status by Central Act, and it came as a Faculty of Pharmacy, Jamia Hamdard, in 1989. And in order to have alignment, it was renamed in 2016 as School in alignment with the US nomenclature. There are 4 departments, and I belong to the Department of Pharmaceutics. We have a D.Pharm course, we have 2 B.Pharm courses, and M.Pharm courses in 8 disciplines. Total about 1,014 students from D.Pharm to PhD, about 55 teachers, 36 lab staffs, and 15 supporting staff. Next slide. The Department of Pharmaceutics is a DST FIST supported and UGC SAP supported department, right? And next slide. Next slide. So just wanted to brief it out that we have about 11 UG, PG and research labs in total, right? And then we have very noted. So next slide, please. Next slide. Next. I just want to finish it off. Next slide. Next. So we have about 8 labs, right? All are having well-equipped laboratories, right, for conducting research on different thrust areas, being funded by DST, i-QSAR, IUSH, DRDO, and many more, grants which are available. Next slide, please. The notable alumni, are spread out throughout the world globe, right? And we have the alumni sitting at USFDA in very eminent multinational companies and so on. Next slide, please. Next slide. Yeah, next slide. So coming to the emphasizing on the demographic data, the epidemiology of breast cancer, right? And in 2016, about 514 DLAs were reported among 1 lakh women, and we say it is a disability adjusted life years, right? And in southern part of India, right, we have a high burden of breast cancer, and accordingly in this epidemiology importance, the i-QSAR project was given as per the first area of i-QSAR. Next slide, please. Next. So the US data talks about 1 in 8 women, and there is a reducing global breast cancer mortality by 2.5% per year because of the lot of treatment modalities available, but there's still a need to have a more effective and efficient breast cancer therapy for the treatment as such, right? Next slide. So we classify breast cancers as ductal carcinoma, lobular carcinoma, inflammatory breast cancer, right? And it spreads starting from the soft tissue and then spread to the skin of the breast, and the breast looks red and swollen, and there may not be any lumps in the breast that can be felt. Many a times you cannot feel the lumps, but it is actually spreading into, and that's why most of the cases are being reported at the later stage of the breast cancer. Next slide, please. When we talk of the stages as such, right, the stage 0 talks about the abnormal cell growth, and stage 1 talks about early stage where cancer is spread into other tissue in a small area. The stage 2 talks about localized tumor size between 2 to 5 centimeter, right? And the stage 3 talks about lesion spread tumor size larger than 5 centimeter. And the last stage is the distant spread where cancer is spread beyond the breast to the other parts of the body and difficult to control as well. Next slide. The cancer primarily being classified as ER positive when these are estrogen receptor presence, and they are also being classified as progesterone receptor positive if there are presence of progesterone receptors. And if the both receptors are present, they are being termed as HR positive, and accordingly, initially, the oncologists also decide upon the treatment modalities on the basis of the presence and negative presence of these receptors. HR negative breast cancer do not have estrogen or progesterone receptors, and the HRT positive, which have higher than normal levels of HERT protein. These protein help cancer cells to grow. So different tests are done in order to find out, in order to decide upon what type of treatment modality to be used by the oncologist. Triple negative breast cancer do not have any estrogen or progesterone receptor, and also do not make any or too much HERT protein. Triple positive cancers are ER positive, PR positive, and HR2 positive. You can see the various classification which talks about presence of 2 different receptors, presence of HER2 protein, and so on, and then maybe a positive or a negative and so on. Next slide, please. The conventional chemotherapy talks about, in case of triple negative cancer, right, there are different drugs which are available, MAPs, particularly anthracyclines are available. And then in the case of triple positive, there are hormonal therapies because these are positive either towards estrogen or progesterone, and these cancers will be treated with hormonal drugs as well as drugs that target HERT if they are HERT positive. If they are ER positive, that is only hormonal therapies, particularly aiming at estrogen receptors, are being taken. Erotomase inhibitors or selective estrogen receptor modulators are used. And if they are PR positive, progesterone positive, treatment with endocrine therapy blocks the growth of the cancer cells. So a very important step in case of the modality to be decided whether these are presence or negative effect of HRT, estrogen, and progesterone. Next slide, please. As I have started with the various stages as well, and then the stages talks about the treatment modalities as well. Right, hormonal, if it is hormonal one or a targeted one, tamoxifen, and then various MAPs which are being laid down, and then these are combinations which are being used as per the stages of the cancer being detected on the basis of mammography and so on. Next slide. This is a review which was presented as a nanomedicine, a promising avenue for the development of effective therapy of breast cancer. Next slide, please. It is very important whenever we are writing a grant or we are writing to a funding agency, it is very important to talk about the importance and the novelty of the theme on which you are going to work. So you have to do a groundwork, you have to create a proof of concept, and then only the agencies are interested in giving the grants. And accordingly, we created a importance. What was the importance, and accordingly it was done. So today I'm going to talk about the lipidic-based drug carriers, right? And how they are of unique in nature, and then what type of advantage we are going to get, and some experience I'm going to talk about as an outcome of the project. Next slide, please. When we entered into pharmacy courses, we were taught emulsions, right? Two invisible liquid mixed together with the help of emulsifying agent, and then associated instability issues, flocculation, deflocculation, formation of cake, and then there is a thermodynamic instability and so on. So in order to improve upon the concept of multiple emulsion came into, and then later on it developed into micro emulsion format, right, which incorporate a high percentage of surfactant. And with the inclusion of stress, shear, the concept of nano emulsion came into, where shearing is going to reduce the particle size with the reduction in the amount of surfactant being used in order to decrease the peripheral toxicity associated with the high amount of the surfactant and so on. And then these liquidic emulsions are always have a problem of stability issues, particularly whenever we are comparing to formulation in the physical state of liquid or a solid one. Solid one is always given higher marks in order to have greater stability. So scientists were always trying to find out strategies by which you can convert these liquid emulsion, the lipid emulsions, into a more solidified form. And the concept of solid lipid nanoparticle came into. The solid lipids are basically the lipid which are having a very structured type of a structure, which is crystalline in nature, right? And since you already know that crystalline substances are also having a lower solubility issues, and that's why the concept of solid dispersion, incorporation of amorphization, and so on is the strategy which is being used by a lot of formulation scientists. Accordingly, this solid lipid nanoparticle was also having a problem of a low payload. You cannot give a high payload to of the drug, and secondly, on storage there was a drug expulsion occurring. So there were certain other stability issues. Because of this was not very primarily being explored to a greater extent. And then the concept of bringing into deformation within the solid structure was the concept which was later introduced. The concept was incorporation of a liquid lipid which is going to incorporate deformation, and accordingly you can incorporate a high drug load, and then the drug expulsion on storage also was minimized. That was the concept, and accordingly we had a concept of nanostructure lipid carrier. Next slide, please. As mentioned already, the issues with the conventional lipid formulation was poor drug loading capacity, when the use of higher excipients leading to toxicity issues. There may be possibility of drug precipitation whenever these formulations, which were conventional when they were taken into by oral route and in contact with the upper GI fluid, the fluid provides a hostile environment leading to the precipitation of these drug candidate, expulsion of drug during storage, and there are toxic effects related with the surfactants and so on. Next slide. As mentioned already, these are unique blend of lipids, and then consisted of mixture of solid lipid with incompatible liquid lipid. Incompatibility is only talking about in terms of the physical incompatibility, because the physical consistency are different, and it is nothing to do with the chemical or other type of incompatibility. Unstable matrix of NLC offers advantage of improved drug loading capacity and release properties beside modulation of delivery profile. So you aim for a control release, right? But you ultimately end up in sometimes sustained release or sometimes getting a control release formulation. Next slide. The concept of fate, why these scientists are more interested in getting lipidic type of drug formulation, what are the advantages. A very common example is of a grusofilmin, which is antifungal, always recommended with a high fat meal. These are highly hydrophobic drug candidates having a high log P value, and when this is being given by a high fatty meal, it causes release of bile salts, right? So bile salt releases certain salts which emulsifying it and then helps in the absorption process. A very common tough example taught to our B-Form candidate. Accordingly, here also, when these lipidic nano formulations are given, right? So endogenous constituent of bile salts form micelles, high concentration gradient, for efficient diffusion across unstirred water layer. Maybe in biopharmaceutical and pharmacokinetics, you have studied about the importance of stagnant layer, unstirred layers, and so on, which plays a very important role in the solubility, intrinsic solubility, in the dissolution profile of the drug as such. Small particle size, but obvious improved surface area, improved drug resolution, and there is a high dispersibility and effective adherence on gut wall, which prolong intestinal residence time as well. So you are able to attain a sustained release in addition. And this unique physical combination of a solid lipid and liquid incorporates direct transfer of drug through intestinal lymphatic into systemic circulation. So the route which is being reported in n number of articles is that it is a lymphatic uptake because of the increase in the size formation. These micelles from chylomicrons, and before entering into the portal network, they enter into the lymphatic uptake, right? And accordingly, it is more suited for drug candidates which undergoes first pass metabolism, which undergoes pre-systemic metabolism, and you are able to lower the dose, particularly in case where drugs are having high first pass. Next slide, please. So benefit is, as mentioned already, I have already covered up. These are micellar of solubilization, drugs with poor oral bioavailability, and then it also imparts metabolic stability in terms of also some of the lipids. They are being reported to be having activity against P-glycoprotein also. P-glycoprotein efflux system is a system which is based on ABC transporters. So earlier it was all poor viability was associated with the solubility issues, but later on it was also detected that the moment the drug is taken into systemic circulation, it is thrown out, it is effluxed out back into the lumen, right? So these lipids also have the characteristics of the providing P-glycoprotein inhibition. In addition to it, lot of drugs undergo intestinal metabolism also. So these encapsulation, the lipidic nanostructures also causes the saving the drug against the hostile intestinal metabolism. Enhancing permeability and if formulated with PK modulators can improve PK profile of drug, preventing degradation. So why I'm mentioning PK modulator, particularly the candidates which are having low permeability, though they may be having a high solubility, they can also be tried in order to have a high permeation. Next slide. This is in the JDBST review, which talks about the therapeutic potential of nanostructural lipid carrier approaches for tackling the inherent lacuna of chemotherapeutics and herbal drugs against breast cancer. Right. Next slide. So drug candidates, so far we have come across the drug candidates which are suited for the NLC formulations are drugs having poor water solubility and a high lipophilic character, may be represented by a high log P value. Potential substrate for TGP, that is, which I have already mentioned. And they are having quickly eliminated, having short half-life, but obviously one of the characteristics for the drug ideally to be taken for sustained release. Suitable candidate for lymphatic transport, maybe you can target a drug candidate which when you would like to target the lymph nodes and so on. Extensively metabolized in intestinal gut and liver by cytochrome P3A4, which is mixed oxidase reductase system responsible for drug first pass metabolism or pre-systemic metabolism and so on. Next slide, please. So there are various methods of preparation. How much time I have? So there are various methods of preparations which are used, as mentioned already earlier, till the stage when we came into microemulsion, no shearing was involved. These were all spontaneous systems. When we are preparing emulsion, these are spontaneous formulation. Accordingly, in the stage of microemulsion, these were all spontaneous formulation, and accordingly, the high pressure homogenization pressure, right?
Recording in progress.
So these are cycles available. You can have n number of cycles depending upon the stability of the drug candidates, right? I will show you some drugs candidates which we have worked on, which are sensitive to heat, and accordingly we have modified the method also so that the less exposure to pressure and temperatures are there. So the shortcoming of this method is lipid degradation may occur at high temperature, and that's why preconditioning is required, right? So next slide. Oil in water microemulsion are very well-known method which is used, right? And is a high level of water content which is difficult to remove. So that's is a shortcoming because we need a system where water is not present, and accordingly it involves dispersion of a warm oil in water microemulsion in cold aqueous medium under mechanical stirring. So mechanical stirring is used for shearing the system as such, and in this system high concentration of surfactants is required. So this is also one of the methods which is being tried at the lab scale as such. Next slide, please. Solvent emulsification, evaporation, diffusion. It is a method which is being utilized for a large number of vesicular structure as well, preparing neosome, liposome, and so on. Accordingly, it is also used for nanostructure lipid carrier. Formulation lipids are melted. Drug is dissolved in an organic solvent which is emulsified in a water bath under mechanical stirring. The aqueous phase containing surfactant. Solvent is evaporated and stable NLC dispersion is formed. Here, these scientists have also started working not only for the drug candidates which are having high log P value, which are water insoluble, but here you can also incorporate a water soluble drug in the aqueous phase in order to form a NLC formulation as such. The shortcomings are toxicity issues with solvent residues on the product obtained. So important to report residual solvent content, right? Organic solvent which we have used, accordingly that is to be reported, and the particle concentration obtained using technique is very low sometimes, right? So the low particle size sometimes interfere with the zeta potential, stability issues, and so on, right? Next slide, please. Here, high shear homogenizer or ultrasonication. This is a method where melted liquid is dispersed in aqueous surfactant solution, which is under high shear homogenization with roto-stator homogenizer or ultrasonication using probe. The obtained dispersion is then cooled down to room temperature. You can avoid toxic solvent, right? So if you don't want any organic solvent intervention, you can utilize this method. And there is a low dispersion quality with presence of microparticles, physically unstable during storage, and low lipid concentration. Surfactant concentration is high, and contamination in metal can also take place. So normally if you see NLC, high pressure homogenization method is widely accepted, and then the solvent emulsification methods as well. Next slide, please. So this is a report which talks about singly handled chemotherapeutic agents in form of NLC formulation in order to enhance bioavailability for efficient, effective, targeted, and so on. Next slide, please. Next slide. Next slide, yeah. So the treatment strategies nowadays which is being explored for the breast cancer is like conventional drug delivery, which the charts which I have shown in terms of the positivity nature of the cancer reported, and accordingly the type of stage which is there, and then the treatment modalities are being selected by the oncologists as such, right? But nowadays targeted drug delivery find more appropriate, in terms of effectiveness and efficiency. Single drug targeted drug delivery or dual drug targeted delivery. So dual drug talks about two different drug candidates mixed together because of the different type mechanism of approach, right? And in case of overexpressed genes, right, and you would like to target them through conjugating with a ligand, right, or a non-conjugated drug delivery with surface modification, so that the drug is targeted toward the target, right, and it is not exposed to the peripheral tissues, right, so you can minimize peripheral toxicity. Normally in all line of experimentation research, always we aim for a high benefit to low risk. The benefit should be high and the risk should be low. Maybe you are trying for an antihypertensive, an antimicrobial, or an antidiuretic, right, and so on. But in case of cancer, the ratio reverses. It says even it is low benefit and the risk is high, then also it is able to save even 5%, 2% of the life. And accordingly, here also the important here is that the organs, the non-cancerous organs should not be exposed to the level of chemotherapeutic agent. And accordingly, like, in case of breast cancer, the folate receptors are overexpressed. So a lot of studies are reported and formulation being tried where the folic acid conjugation being used in order to target those folate receptor by bringing surface modifications and so on. Next slide, please. So this talks about the mechanism of uptake of targeted nanocarriers, talking about nanoparticulate system, talking about ligands like certain peptide, hyaluronic acids, antibodies, and folic acid particularly, maybe passive targeting. There is an effect which is known as EPR effect. EPR effect. Any student can tell me EPR effect of cancer cell? Anyone from the audience? EPR effect? It is known as enhanced permeation and retention effect. So these cancerous cells, they have high permeability. So nature has given, the nature of cancer cells to be highly permeable. So the moment if they come in contact with the chemotherapeutic agents, they are taken into. And in addition, the nature has given another type of activity where they are retained for a longer period of time. So that's why the cancerous cells are being termed as having an EPR effect, right? And the next is the active targeting. You target them through endocytosis, exocytosis, transcytosis, and so on. Next slide, please. These are examples which I've just given in the previous slide, talking about folic acid, right, and then some of the aptamers, antibodies, right, in order to attain selectivity and specificity in particularly bringing surface modification in particular. Next slide, please. So this is one review which talks about folic acid modified precision nanocarriers, charting new frontiers in breast cancer management beyond conventional therapies, right? Recently, that was published, right? Next slide, please. Now, the benefits of dual targeting drug is like you combine together two synthetic moieties, right? Synthetically available chemotherapeutic agents, maybe a MAB or a hormonal one, overcoming inverse or multi-drug resistance property of the chemotherapeutic agents, right? And then large number of phytoconstituents are also being reported. So they generally aim to be synergistic in effect. They have an anti-inflammatory, anti-proliferative, and antioxidant. So the cause for cancer is being reported as oxidative stress. So a lot of studies are being done where antioxidants are being incorporated from the phytosides as such. And then, but obviously two different type of phytoconstituents which have activity against breast cancer and all they are being tried. Next slide, please. So assessment of a combination approaches for phytoconstituent with chemotherapeutic for treating breast cancer, a systematic review was done in order to identify what type of drug candidates to be taken into and then accordingly the strategy to be decided upon. Next slide, please. So here I'm going to talk about a strategy where this is being, already I mentioned is an ICMR funded where ribociclib, a very prescription drug, right, which is used for cancer treatment with GT is the green tea extract, and this extract was used primarily because of the presence of the isoflavone, right? So phytoconstituents have a biological activity like anti-inflammatory, already mentioned, anti-proliferative, antioxidant, and anti-cancer properties. They prevent cancer cells by blocking the ER, and isoflavones are used, and then some of the lignans are used, polyphenols and flavonoids are used, and this GT is primarily consisting of epigalactocatechin galates which are present primarily and demonstrated to suppress both growth and angiogenesis and to increase apoptosis in breast cancer cells. And accordingly, this was mixed with ribociclib. Next slide, please. In silico studies were done in order to establish the the targets as such, right? And both drugs were studied through a collaborator for in silico studies, and based on the glide score and docking score, these showed promising binding result to CDK4 receptor, which are overexpressed in case of breast cancer. Next slide, please. Breast cancer cell line studies were done through in MCF7 in order to have a dose-dependent cytotoxicity both for the synthetic moiety, that is ribociclib, and the green tea extract, and their IC values are calculated in order to find out the combinational values to be used for the formulation as such. Next slide, please. So cell line studies for both drugs were there. The combination drug approach for Synergistic effect further confirmed by putting all MTT assay values for each ratio, and a combination index was taken and 1:10 values were taken into. Next slide, please. The major ingredients of NLC, as mentioned already, consists of a soil lipid and a liquid lipid and its surfactant, right? And we try to go across various types of soil lipid, liquid lipid, and surfactant. The concept of finding out the solubility in these oils, solid lipid or liquid lipid, is that it should dissolve the highest level of the dose, because you have to dissolve a dose. So unless and until your dose goes into a solid liquid or the liquid lipid, it is of no use, and accordingly these studies are done. Next slide, please. And the selection in the liquid lipids were done based on the solubility, the labrafil. These are the getaphosphate liquid, physiological lipids which are used, right? And camphene, benzene, and purol are showing the highest solubility of ribosiclib, as it expected. Their structure containing carboxylic acid and succinate group favors the solubility of ribosiclib in such lipids. Also, longer triglycerides showing more solubility compared to medium chain due to more entrapment drug. So generally, these liquid lipids are also being classified on the basis of the medium chain, long chain, right? And accordingly, what type of characteristic these liquid lipids are going to provide for solubility, they were selected. Next slide, please. The solid lipids talked about different solid lipid, and the stearic acid, which was having an HLB value of 17, and camphene MC was selected, which was showing high solubility of ribosiclib, and it is also expected the same structural relationship in terms of the group inference. Next slide. In order to find out the compatibility studies of these liquid lipid and the solid lipid, thermal analysis through DSC, in order to find out the crystallinity index was done, and as percentage of liquid lipid increases by 10%, the enthalpy for the melting point decreases in respect of the solid lipid. However, the crystallinity index having less variability in ratio of 8:2 or 6:4 compared to 9:1, so final ratio was selected based on the crystallinity index, that is 6:4. So what combination of the solid lipid and the liquid lipid was taken, that is being selected. Now this combination is particularly used in order to solubilize the drugs which we are going to use. And then screening of surfactant was also done in terms of finding out the percentage transmission of the dispersion, which was depending upon the particle size as such. Next slide, please. Compatibility studies in terms of establishing the compatibility with the drug and the excipient was done, as in order to find out there is no interaction occurring with the drug and the liquid lipid, lipid lipid, and the soil lipid, and so on. Next slide. So the optimized formula was ribosiclib and GT in the ratio 1:10, and the binding mixture 1% weight by weight was taken. Surfactant, sonegation time of 3 minutes, and aqueous phase was 10 ml as such, right? Next slide. Having not included QBD graphs, contour graphs, and so on, so it was a systematic approach with the incorporation of DOE experiment and so on. They were characterized both for the particle size, right? They were characterized for the zeta potential, and for surface topography, we did 10 studies in order to find out what surface structure these nanoparticle system was having. Next slide, please. In vitro analysis in different media, right? We used a simulated physiological upper gastric pH of 1.5 and the proximal small intestine pH of acetate buffer pH 4.5 and SIF, that is the simulated intestinal fluid of pH 6.8. Next slide, please. So it talks about in terms of percentage resolution efficiency, talking about the similarity factors T 15% and T 75%, and accordingly it showed the highest in case of the upper GI fluid, that is the pH 1.2 replicated by 0.1 normal STS. Because when I'm talking about the physiological pH, it is not incorporating any enzyme. When I'm talking about SGF, it talks about incorporation of pepsine in the SGF and pancreatine in SIF. So the pH accordingly representing the physiological pH was used. Next slide, please. So in vitro analysis in different media was done in order to find out the percentage of cumulative drug release and finding out that the better release pattern was obtained when the pH 1.2 was used. Next slide. Next slide. After this, the in vitro permeation studies, in order, because we are talking about permeation and permeation very importantly, accordingly these in vitro permeation studies were done, and the percentage cumulative drug permeated was found more in case of combinational analysis formulation as compared to the combinational suspension of each drug molecules as such. So it was showing that not only the lipid was able to incorporate or enhancing the solubility, but it also enhanced the permeation and so on. Next slide, please. In vitro depth permeation was also quantified through confocal microscopy, and accordingly the penetration of drug in the small intestine after 2 hours was studied, and then the percentage in micrometer was reported. Next slide. These are cellular uptake studies in MCF7 cell line, and it showed that the combination approach of NLC was superior in order to comparing with the other drug per se A and drug per se B and so on. Next slide. Intracellular reactive oxygen species, because I mentioned that one of the cause which is being reported for the cancer is the oxidative stress, and the property which is being possessed by the GTE is the antioxidant property. We just wanted to quantify the intracellular reactive oxygen species and superoxidase dismutase assays were done on the cell line in order to find out that whether they are showing antioxidant activity, and accordingly they were showing antioxidant activity more in case of NLC preparation when compared with the combinational suspension preparation as such. Next slide, please. In vitro lipolysis studies were done where these lipidic nanoparticles were digested with a digestion buffer in order to find out that what is the amount of the drug present in the aqueous and the non-aqueous phase, and this sediment is being reported. Percentage of drug content was also calculated over lipolysis in different phases. The whole content was centrifuged to separate the layers of aqueous phase, lipid phase and sediment. Drug release from the lipid content after the lipolysis, the percentage drug release was found more in aqueous phase compared to the lipid phase. So this is an indication that the drug is available in more solubilized form for permeation as such. Next slide, please. In vitro hemolysis study was done as a precursor for the acute toxicity in order to find out there is no hemolysis occurring. Next slide, please. Pharmacokinetic studies were done with the estimating various pharmacokinetic parameters in terms of relative bioavailability, comparing Cmax, Tmax, and area under curve. Both area under curve from 0 to T and 0 to infinity. And the ribosective suspension was compared with ribosective NLC. Next slide, please. And this was also, as a ribosective nanostructure lipid carrier. It was published in Biomed Research International. Next slide, please. This was also compared, ribosective GT suspension was also compared with the NLC formulation as such. Next slide, please. The Cmax, AUC values and the T half values were also compared for suspension and NLC formulation, and it showed a higher relative viability when NLC formulation was compared with the suspension formulation. Next slide, please. This was also published in Journal of Drug Targeting as a combinatorial review of ribosective and green tea extract mediated nanostructure lipid carrier for oral delivery for the treatment of breast cancer, utilizing in silico, in vitro, and in vivo studies as such. Next slide, please. Histopathological analysis were done in order to find out that there is no acute toxicity being reported. Next. Stability studies were done right at 25 plus minus 0.2% as per the ICH protocol. Next. So I have taken you from the how we initiated the concept and then ending up with the in vivo results, and it showed potential by viability enhancement for ribosective and effective breast cancer therapies. And the study demonstrated NLC of ribosective and their combinatorial approach in an extremely potential for enhancing the therapeutic prospect. Next slide. NLC is a potential approach for improving oral bioavailability of highly lipophilic drug, which are having a high log P value with poor aqueous solubility, extensive fast pass metabolism, and affinity for PGP efflux transporters, and susceptibility to intra-enterocyte metabolism, which talks about intestinal metabolism. In a way, high caliber of NLC system shadows the petition of other lipid-based dosage forms. Disrupted matrices of NLC consequently leads to higher drug loading, high drug entrapment, modulated drug release, and ultimately enhanced drug absorption as compared to the other lipidic formulation like SLN and liquid entraps having uniform matrices of lipids. These special features of NLCs are exclusively attributed to their unique composition, which is constituted of a blend of incompatible solid and liquid lipids as such. The promising results obtained using NLC in animal models suggest that the formulation should be extensively tested in human subject number one, and in vitro model studies, preclinical and clinical data on a wider range of drug candidates with different physicochemical properties would help elucidate the mechanism of action of NLC formulations. Exploration of the potential of NLC formulation in improving the absorption of highly lipophilic drugs in conjunction with thorough understanding of the effect of formulation components on efflux transporter, metabolic enzymes, and lymphatic uptake would help in completing addressing all the negative aspects of the oral delivery of lipophilic drugs in particular. Next slide. Next. I would like to acknowledge one of my colleagues, Dr. Sanjula Babuta, right, and my doctoral students, right, who have done their PhDs and who are doing PhD with me. Next slide. This is the list of M.Pharm students, right, who have graduated with various, dissertation topics and so on. Next. This is our research group. Next slide. This is a core group working on lipidic nanocarriers. Next slide. Thank you for your patient listening, and I will help you to clarify. Okay, thank you.
Thank you so much, sir. The session was truly brainstorming. Now the room is open for question answer session. Delegates who are willing to ask questions, please raise your hands.
Sir,
Yeah.
so the session was really very informative. Thank you for that. I have one question, sir. You talked about dual targeting approach. You mentioned 3 types. One was chemo plus phyto. So is there any such combination available in market now in clinical use?
No, it is not available in the market so far, right? So there are only the research reports which are there, but maybe one day it will see the market as well, right?
Yes.
Because ultimately the anti-cancer agents originated through phytoconstituent only. You talk about Taxol, you talk about vincristine, and so on, right? So we are hopeful that something will come out someday.
Yes. So one more thing, you mentioned combination index. So can you elaborate on it, how it's calculated?
Because the phytoconstituent dose is not known, right? So there's a software which is available for combination index. We put into the IC value of the synthetic moiety chemotherapeutic agent which we are using, and then putting the values of ICs at different ratios with the phytoconstituent. So if they give a value less than 1, and then that combination index is being taken in order to use in the formulation, because that dose is not known.
Thank you, sir.
Yes, sir, please.
Hi, sir. Lecture was very good. My question is that for ARV project, after 5 years, there is a lenacapavir injection is coming, and conventional drug delivery system is going to stop. For the breast cancer therapy, after 5 to 10 years, what are the new drugs are coming, and how the pharmaceutical industry is developing that drug?
I think on the 5th or 6th slide I've shown, not a single drug is the treatment modality for the cancer as such, right? So you have to first diagnose what type of cancer it is, what type of positive or negative one it is, and accordingly and at what stage it is, right? So because it is very important what stage the cancer is there in the metastasis in the breast cancer, and accordingly the therapeutic modalities are being there. And always, you will find so many maps coming into monoclonal antibodies, combination of a chemotherapeutic agent with erythropoiesis inhibitor and so on, they are available. So still work is going on, and medicinal chemists are working on more, therapeutic, actively, synthetic moiety which have lesser side effect. Because here the side effects are more prominent rather than the benefit as such, as I mentioned in between that the the benefit is low and the risk is high. So scientists are working on to reverse the order of having a high benefit to low risk, right? Okay, thank you.
Thank you, sir. As we have organized this conference on online hybrid mode, I request technical team to please check any questions are raised online mode. Please check the chat box. By Dr. Javed Ali sir is over. I request Chairman of the session, Dr. B.S. Kuchekar sir, to conclude the session.
I have one question. Your drug delivery system, what you have explained here, is there any such type of drug in the market? Chemo or chemo-phyto or phyto-phyto?
Chemos are available, but chemo-phyto still work is going on, right? And I said in one of the answers, I clarified that the origin of anti-cancer cane started with the phytoconstituent only when you talk of Taxol, vincristine and so on, right? So maybe sometime we will like to see those type of combination also.
Earlier when we were doing the research, rifampicin and grape juice like this, phyto and chemo. The same thing is.
There is something like food drug interaction.
Food drug.
So that is, but here we will see something because many pharma companies are working on those areas because they wanted to come up for filing and all. Let's see something of that sort.
Yes. Thank you, sir. Is there any question? Okay. Now I am summarizing the session. Dr. Javed Ali has started his session with the introduction of the topic, has mentioned the conventional therapy as well as current therapy which is available. Okay, he has highlighted the most important topic, that is lipid-based drug delivery research. And the delivery systems are liquid emulsions, solid lipid, nanoparticles, nanostructured liquid carriers. Also, some issues and challenges with conventional lipid-based formulations. He explained with poor solubility, poor bioavailability, poor loading capacity of the drugs. And is the main research area, NLC, drug encapsulated NLC lipids, lipophilic drug. And he explained this with glycopholvins, right? He has not forgot to give the benefits of NLC by oral route of administration, like solubility, bioavailability, and most importantly is loading efficiency of the drug selected. And he has supported this with his research publications in reputed journals of elsewhere. Further, he mentioned the selection of drugs for NLC and methods of preparation of NLC with advantages and shortcomings of each method. He explained all this with the examples of doxorubicin and tamoxifen. The main topic is treatment strategies for breast cancer, and my friends, the scholars, targeted drug delivery system not for only single but also dual drug delivery system. Just we have seen the chemo-phyto is also there, and the research is going on chemo-phyto and phyto. He has supported his research work with the research publications and review articles. I would like to tell the budding researchers or research scholars or our students that writing review article is very, very difficult. It requires authority like Honorable Dr. Javed Ali. Why I am telling, if you want to write the review article, it should be authority. Authority meaning at least 5 to 6 papers research paper on that topic should be to your credit. Otherwise, you are not authority to write the review article. Our students at MPAM or say even UG students, they are writing review articles, but they are not review articles. You can call it as a special article or otherwise. See, as explained, the research articles on Reebok cyclip with green tea extract, which is really commendable, sir. Research on your side. My request, I think this will be beneficial to our researchers, and researchers will definitely adopt this technology of NLC or even dual drug technology in their research, sir. Thank you so much for your informative explanation. Thank you, sir. And I thank the Modern College of Pharmacy in Nigadi for giving us, both of us, opportunity to co-chair and chair this scientific session. Thank you so much.
Thank you so much, sir. Such a wonderful conclusion. Now I request Chairman Dr. B.S. Kuchekar to felicitate Speaker of the session, Dr. Javed Ali, with memento, certificate and floral bouquet. I request Principal Dr. P.D. Chaudhary sir to please join them on stage. Please have a big round of applause. Thank you so much. I request Co-Chairman Dr. Vikram Gharge to felicitate Chairman of the session Dr. B.S. Kuchekar with memento, certificate and floral bouquet. Please have a big round of applause. I request Principal and Convener of the conference, Dr. P.D. Chaudhary, to felicitate Co-Chairman of the session, Dr. Vikram Gharge, with memento, certificate and floral bouquet. Please have a big round of applause for the eminent personalities we have on stage today. Thank you, sir. I request Principal, sir, to please escort the dignitaries off the dais.
Second scientific session will be conducted by Dr. Vijay Masand. He will give a scientific talk on artificial intelligence and i-QSAR in drug design and discovery. The scientific session will be graced by Chairman of Session, Dr. Satish Pardesi, Senior Professor and Head of Chemistry Department at Savitribai Phule Pune University, and Co-Chairman, Dr. Sachin Agawne, Senior Principal Scientist at National Chemical Laboratory, NCL Pune. I request Speaker Dr. Vijay Masand, Chairman Dr. Satish Pardesi and Co-Chairman Dr. Sachin Agawne to please come up on stage and have a seat. I am honored to introduce Dr. Sachin Agawne, a distinguished leader in pharmaceutical research and development. Dr. Agawne sir holds a PhD in biotechnology from Pune University. He is also a professor in biochemical sciences at Academy of Scientific and Innovative Research, Ghaziabad, and an overseas research faculty at RMIT University, Australia. With over 20 years of research experience, Dr. Agavani has made significant contributions to biotechnology, having worked at prestigious institutes such as Indian Institute of Chemical Technology, Hyderabad, Poultry Diagnosis and Research Laboratory, Hyderabad, and many more. Additionally, he has been serving as a CCACA nominee under the Ministry of Animal Husbandry and Dairy, Government of India for past 18 years. His scientific contributions are remarkable. He has guided numerous PhD research scholars and postgraduate students, published over 55 research papers in internationally reputed journals, and holds multiple Indian and US patents with more than 1,300 citations. His expertise has also played a pivotal role in organizing conferences, seminars, and training programs. Beyond academia, Dr. Agavane has been instrumental in supporting pharmaceutical and biotechnological industries in technical, regulatory, and validation process. He has also been a driving force behind establishing the state-of-art laboratory animal house facilities at premier institutes such as NCL, i-QSAR Pune, and IISCT Hyderabad. A respected member of global scientific community, Dr. Agavane sir is a life member of renowned organizations including Society of Toxicology USA, Laboratory Animal Scientists Association India, Indian Association of Veterinary Pathologists. With his vast expertise, groundbreaking research, and commitment to scientific advancement, Dr. Sachin Agavane sir continues to be a beacon of innovation and excellence in biotechnology and life sciences. Now I request Dr. Sachin Agavane sir to introduce the chairman of the session, Dr. Satish Pradeshi sir.
Good afternoon. It is an honor to introduce Dr. Satish Pradeshi, a distinguished senior professor and head of chemistry department at Savitribai Phule Pune University. With over 33 years of teaching and research experience, he has made significant contribution to the field of chemistry, material science, catalysis, environmental science, and energy storage. Dr. Pradeshi has received multiple accolades, including the Young Scientist Award, Best Researcher Award. He is currently the Vice President and Life Fellow of Indian Council of Chemists and Fellow of prestigious Maharashtra Academy of Sciences. His pioneering work in microscale experiment in inorganic chemistry has been widely recognized with over 35 workshops conducted across India. He has authorized 81 research papers and over 120 conference publications, mentoring 11 PhDs and 5 MPhil scholars, with several students currently under his guidance. As a respected reviewers for leading international journals such as ACS, Elsevier, RSC, Dr. Pradeshi has reviewed over 80 research articles. He has also delivered 70 plus invited talks at national and international conferences. Beyond research, he has played a vital role in academic development, contributing to the syllabus designing and curriculum enhancement for various institutions. He serves on academic board of KBP University and VIIT, and he is a board of study member for multiple colleges across India. So I welcome Dr. Pradeshi. Thank you.
Thank you, Agavane sir. Now I request Dr. Satish Pradeshi sir to introduce speaker of the session, Dr. Vijay Masand.
Thank you, Agavane sir, and welcome Professor Masand. It's a great pleasure to introduce Professor Dr. Vijay Masand. He is currently working as professor in the Department of Chemistry at Vidya Bharati Mahavidyalaya, Amravati, Maharashtra, India. With over 21 years of teaching experience, his research focuses on organic synthesis, chem informatics, and computer-aided drug design. He has published 147 research papers in reputed journals such as ACS, Nature, Elsewhere, Springer, YB, MDPI, and Frontiers, with a total impact factor exceeding 290 and more than 2,300 citations.
His H index is 28, reflecting his significant contribution to the field. Professor Masand holds 4 national and international patents and has presented his research at over 100 national and international conferences. He has authored 5 books which are published in Elsewhere, Lambert, and Bookrix, and a book chapter with Elsewhere. As a PhD guide, he has guided 5 research scholars. He has served as a resource person at numerous international, national, and state conferences, and he is also an associate editor for Frontiers in Chemistry with an impact factor of 3.5. His global collaborations span the US, UK, Italy, Morocco, Russia, Singapore, Malaysia, UAE, and many other countries. Professor Masand is a member of American Chemical Society since 2024 and has held key academic positions including Board of Studies in Chemistry at Sant Gadge Baba Amravati University, Amravati, and also in medicinal chemistry for Solapur University, Solapur. In 2024, he was recognized among the top 5% of scientists worldwide. Additionally, he ranks 518th, that is top 1.1% among 47,186 scientists in drug design and 2.42% in medicinal chemistry. So we are having a great personality with us. We welcome him for the today's talk. Welcome, sir.
Thank you, sir. We're really delighted to have such eminent personalities here with us today. Now I request speaker of the session, Dr. Vijay Masand, to start his scientific talk.
Dear participants, am I audible? Yes. Thank you. So first of all, I am thankful to Dr. Pardeshi for the nice introduction. We have a long bonding, sir, I think from 2012. I attended the experimental chemistry refresher course. And he himself is a source of inspiration for me because he is doing a lot and working for the students. So thank you, sir. And I'm also thankful to Dr. Alone. He's here, keenly watching me, whether I'm speaking truth or not. Then, thankful to Dr. Sundat Chaudhary. He called me once and asked me to be the resource person for this international workshop. I will call it workshop. That's soon you will understand why. Thank you, Dr. Sundat. I'm really grateful to all the organizers, especially the principal, the management of this college. If I forgot anyone, kindly forgive me. So I'll start this session with something which is in demand. We want to work and we don't have so much of resources. So what we think, someone should help me or some easy peasy way should be there. Am I correct? Dear students and colleagues? Am I right or wrong? Please reply. It should be two-way. Right or wrong? So let us start with your mobile. Okay? So your mobile is a very good, powerful tool. I've always used it for my benefit. I'll try one special training to you. Is it allowed, sir? Okay, so open your mobile and go to the browser. It could be Google, or it may be Chrome, or it may be Mozilla, anything else. I also request the computer handler, computer operator. So in Google, just write down the keywords. If suppose you are searching for any specific topic, then the word should be there. For example, I am working on isoxazole. Since I am a person from chemistry, I will definitely go for chemical names. If suppose I am working on nanoparticles, or if I am working on anything, just write down the keywords. That is why the keywords are asked in the literature, in research papers. So if you have typed it correctly, then give space. Okay? Then what usually people do, they write down PDF. Am I correct? Do not do this. You are doing it halfway correctly. The correct way to write down file type. FILE file type. So write down any word. You can write down name of any actress also. You can just write down the name any. Pyridine, for example, PYRIDINE space file type. You can write down in small letters or in capitals, doesn't matter. File type colon. Now there is a need of colon, not semicolon, 2 dots. Colon, yes, colon, and then write out the word PDF, because most of the research papers are in PDF. Just write down PDF. Now we are telling it to search for the PDF copy. Okay? So PDF copy, then hit enter. And only PDF copy of research papers will be available there. You can see it here. I need one pointer, laser pointer. Is it available? Please scroll down. So you'll see a lot of papers are there. If any of the researcher has deposited his or her paper in any internet repository, any archive, then it is now available to you. And it's not you are doing any hacking. It's simply you are telling the browser to connect to the depository and download it. Okay. So now the papers are available in PDF format. Second, instead of PDF, if suppose you are looking for PowerPoint presentation, just simply replace PDF with PPT. The students are very happy, sir. Now we can prepare PowerPoint presentation on any topic. Really great, sir. Where you were? I was in Amravati. Okay, Amravati, the capital of heaven. So PPT. Now don't stop here. If you are looking for any specific image, you can use JPG. That is why the file format is very important. So JPG. Even you can find out the EXE. That means executive file of any software. Just replace PDF with EXE. This is how we identify where the software is available. Okay. So no need to search whole. Now this is one type of working. Remember, I am a man from chemistry working in cheminformatics. Now cheminformatics is a topic which involves chemistry with information technology. Okay. So now this is the correct use of information technology. One more thing. Whenever the papers are uploaded, they are mostly available with certain pattern. That is called pattern identification. So if you open any elsewhere paper or any ACS paper, they are giving you some ideas how you can download their papers. Okay, because those are available online. Behind the paywalls, but we can crack it very easily. Okay, let's see how. See, download any paper which is belonging to elsewhere, for example. Please, just write down any keyword, any word, and then write down elsewhere journal. Please write down correctly, because correct English. Yeah, elsewhere journals. So download any paper from elsewhere. If it is not available, I can provide. It should be PDF copy. Okay. So in PDF copy, they are giving you the location of the papers they have deposited. You know. Don't tell this technology to anybody else outside this room. It's a top secret. Okay. Okay. Open. See. Go to the view PDF, please. You are creating the problem. Go back. Once again, click on view PDF. Okay. I think today is Monday. So there should not be any problem. Okay, but see, when you will see, there is specific word elsewhere.com/locate/ and there is the name of the journal in short form. I always use this idea to capture all the papers. Whichever paper I want, I get it legally. Okay, this is the power of chemistry and information technology hand in hand.
Now, being a person from software technology, I want to know how many of you are having chemistry background. How many of you are doing informing pharmaceutical chemistry? Just raise your hands. So there is a good number. Okay, and most of them students. And from faculty, how many are from pharmaceutical chemistry background? Good. Okay. So this is a session going to useful to all actually. Now one more thing, it is generally asked to me, sir, is there anyone who will help me in my research? The answer is yes, computer. Okay, so this topic is going to that. And during my topic, I'll go here and there. I will jump just like a monkey, okay? Please start my PowerPoint presentation if you have copied it correctly. Photo अच्छा है ना? Please. Have you copied it in the computer? Okay, please start it. People, sir, and I need laser pointer. Sir, is it available? It's not allowed. Okay. Oh. No, thank you. It's okay. I'll manage. So welcome to everyone. And next please. Turn off your mobiles if it is not, because for next 1 hour I am your Google, I am your Facebook, Instagram, Reels, everything I am. Okay? No need of all these things. I saw some of the people who are scrolling. Next please. So today's topic is very, very different. It's because the topic is AI, Artificial Intelligence, and i-QSAR. This day marks the beginning of one more type of QSAR, that is i-QSAR, that is interpretable QSAR. It's a new branch in this drug discovery. Okay, so we'll deal about mostly AI and i-QSAR. Next please. So here are some proof that I was unfortunately out of India. You can see with me Dr. Taibi Ben Hadda from Morocco, Dr. Pirilu Jendre from France, Dr. Hafid from Morocco, Dr. Vesna, and Dr. Agej. I don't know who is this man coming everywhere. I have no idea. Okay, next please. Next. So I'll always start with this something which is very important to understand and distinguish. The first thing is drug discovery. Obviously, discovery means to find out something new. Okay, so finding out the new therapeutic action is known as drug discovery. For example, we are knowing about aspirin, which is very famous for headache. Okay, obviously after my lecture you will feel it. And penicillin, it was accidentally discovered that it has antibiotic activity. Am I correct? Yes. So this is discovery. What is designing? Actually, this word drug designing is perfectly wrong. It's wrong word. But why it is used is very important. Drug designing is purposely identifying the molecule and modifying its admit property: absorption, distribution, metabolism, excretion, toxicity. Dr. Javed Ali already told you it's the toxicity which is the biggest hurdle in drug designing and discovery. So you have to be careful about toxicity. You have to minimize toxicity of a molecule. Okay. So when you do this, you are doing drug designing. Now I'm calling it misnomer because the correct word is drug tailoring. Now if you call you tell someone I am doing tailoring, you will not get the respect. That's why we are using a catchy word, drug designing. Instead of calling a tailor, call him fashion designer. Drug designer. Another correct word is drug engineering. But since we are not doing engineering, we are doing a discovery and designing. Okay. One more word is there. One more click, please. And that is drug delivery. Already you all listened a very, very powerful and very informative lecture from Dr. Ali. So I'm skipping it. Next, please. You'll see the one more word, that is drug development. And unfortunately, in India, we are using these words synonymously. Drug development is compromising all these things: drug discovery, designing, and delivery. Whereas drug discovery means specifically find out new action, repurposing a molecule. A drug is already known for cancer. Now you are using it for COVID-19. It is discovery. if you're identifying a molecule and modifying it for your purpose, optimum admit, then it is designing. Okay, and delivery now you know. Next please. Now this is the actual thing required, which is the timeline. Most of the time we ask when the drug is in the market. You know, during the period of COVID-19, you remember? So they were asking all the doctors, the physicians, when the drug will be in the market. And now you being the person from pharmacy background, chemistry background, we know it takes a lot of time, at least 10 to 15 years. Okay, and it is not the job of physician or doctor to develop a drug, it's our job. But no news channel asked me to come there and tell this thing. They were asking someone who is not knowing the ABCD of everything. That's why we have to work hard. We have to propagate this message to the society that it is the people of pharmacy and chemistry are working hand in hand to develop the drugs. Okay? Now, there is one word there, you'll see the AI universe. Soon you will know why AI is a new thing, but actually new for others, not for us. Now, in case of drug discovery and designing, we use 4 different areas. You know, the SAR, structure, activity, relationship. QSAR, quantitative, structure, activity, relationship. Then molecular docking, and one more thing is there, pharmacophore modeling. We all are capable of doing this with the help of computer. And nowadays, AI is the top of the town. Let's go ahead, please. Now, in case of modern trends, we are relying on AI. People are calling this AI. But why AI is required? Let's see. This is because AI is used for better compounds into therapeutics or clinical trials. It's marvelous, really marvelous. Second, we can develop and identify the targets very easily with the help of AI. It's being done. Third, we have the battle control clinical trials. For the surveillance, it is one of the best. And last, it applies to every aspect from messenger RNA to membrane proteins and each and everywhere. That's why AI has become talk of the town. Everybody is after AI, artificial intelligence. But my personal opinion is saying something opposite. We don't need AI, we need AI. AI, actual intelligence. It's here or here? No, sir. After your lecture, it will be here. Actual intelligence. We need adequate intelligence. Not only you should have actual intelligence, it should be adequate for drug design and discovery. You need to apply the intelligence. So applied intelligence. So we need AI, but not artificial. We need actual. We need adequate. And we need applied intelligence. Then we can develop a drug. Okay? But right now I'll have to prove scientifically that it is wrong. Let's go ahead. One single click, my friend. Okay, I will tell you about this. I will come back. Okay? Next. Okay. So before starting this, if someone is very much interested in doing AI at home, he can or she can, because Women's Day have recently celebrated. Okay. So you need our statistical program, and all our programs are easily available. They are free of cost available. And if it is free of cost available, we Indians will never use it. Okay. Our statistical programs. In fact, for AI and drug discovery, they are specific. Just write down CADDR program. You will get bunch. Second is RD kit. This RD kit is a software which is very, very famous. It is Python based and easy to use. Nowadays, majority of softwares which the people are using, like Schrodinger or anything else, they are actually based on RD kit. They are using it behind the curtains. Next is 9 workflows. A lot of 9 workflows are available. With the help of it, you can automate each and every step. 9 is nowadays very famous. We call it as knowledge workflow. And in reality, people call it as automate workflow. Then you need to know TensorFlow. And for TensorFlow, you need to have very powerful machine, powerful computer with powerful GPU. Okay, my recommendation is to have at least a GPU 3060 with 12 GB, not 8 or 4, 12 GB RAM plus more than 3000 GPU cores. Then and then you can use TensorFlow anywhere. If you have higher grants, you can go ahead. Okay. Then one more thing, we need Python language. A little bit of knowledge of Python is very beneficial because everything is going in Python in AI and interdisciplinary. A lot of softwares are available on GitHub. It's a huge resource. In fact, right now the development which is going in AI is because of this. Okay. Then DTC Labs. DTC Lab is maintained by Honorable Dr. Kunal Rai, and he has provided majority of softwares available for QSR absolutely free of cost. Everything is free. Just register, download it, and get it. And these softwares are available with manuals. Then Conda. Conda is Python package manager, just like your package manager in your mobiles. Then AI Sim, Jupyter Notebook, all these things are also required. So remember, if you want to start, you just need a good computer. My recommendation is to have at least i5 level of computer with 16 GB of RAM, okay, one good GPU, then you can start the work. No need of looking for resources. I need this laboratory, that work, nothing. Even at your home, you can do it. Right now, if I'm here, my computer, which is in Amravati, is still going on. It's doing MD simulation, sir. So the work is going on, it's not non-stop. So you just need, okay, a good computer for this. Next, please. One single click. Now, why AI is not problematic for us, especially for the weak chemistry people? Now, identify my good friend, my old friend. Go on. Surprise? You don't know? My old good. Okay. So just like you, I gave the same question to AI. Next, single click, please. And like you, AI, single click, it identified. One more click. Okay, one more click. One more. And this is the reality. Camera man, either. As soon as Baraka move is there, cameras are always there. So I'm coming back there. Huh? So what happened here? AI has failed miserably. You can see if they are doppelganger or twins, it fails. So when there is a high similarity level, even if it is 99% accurate, what actually happens in case of drug discovery? AI is 99% accurate. It is wrong for only 1%, and the drug is belonging to that 1%. How it happens? Let's see few more. And why it happens? See, this is, just go back, just a single. This is because it is trying to identify the pattern behind it. They call it as graph neural networks. They just try a graph, and on the basis of this graph, the software is trying to identify the person. And if it matches someone, it is now clicking you that the same person is Barack Obama. But there is a glitch. Okay, next more. Now, here is one molecule, which is a troponin I interacting kinase, TNNI3K, and its IC50 is 8000 nanomolar, and its analog, which is comprising only single atom substitution. See, the whole molecule is same, and only one nitrogen is there now, instead of a carbon. Now what happens? AI predicted that so the molecules are 99% accurate, they should have approximately the same activity values. And it predicted 7800 nanomolar. But when the actual experiment was carried out, on single click, you'll get the surprising result. Single click, please. And this was the experimental results. 8000 on one side, 80 on another side. Who did this? A single atom change. Now this 1% is very important for chemistry. Okay. And the reference is there. One more click, please. This is the reference. It happened in 2015. Okay. You might say, sir, it happens by chance. Accidents are everywhere. Exceptions are everywhere. But no. Let's continue. One more example. Now this is the molecule used for splint tyrosine kinase. And its IC50 was found to be approximately 8.8 nanomolar. Its nitrogen analog was prepared. Again nitrogen, because it's generally found that nitrogen containing drugs are more in the market. And again, AI predicts very close, but in reality, once again, there was huge difference, almost 150-fold. Okay, so this is showing that whenever we are relying on AI too much, we may get wrong results. Are you getting the point? Are you getting or not? Yes, sir. This one, yes, sir, or yes, sir, this one? Okay. Well, this is another example. One more. Now, why it actually happening? See, the reason behind it was the hydrogen-hydrogen interaction. The repulsion is there. Because of this, they are unable to interact. Whereas, when there is nitrogen, this nitrogen is attracting the hydrogen from adjacent ring, creating intramolecular, within the molecule, hydrogen bonding. And because of this, the molecule is very, very stable. It is not rotatable. It is more rigid, and hence it is able to accommodate inside the cavity perfectly. And that is why it has difference in the activity. And hence, we can say that whenever there is AI, we need to interpret why it is saying the result, what it is giving the result. That's why I said i-QSAR is beginning today. Okay, let's go ahead. So, since AI has failed every now and then why it is being given such a hype? Okay, this is because the companies are there. And we still believe that AI is actually based on machine learning. Machine learning means we learn, okay, and then we make different types of models. Now this modeling, in case of pharmaceutical chemistry or in drug discovery, is known as QSAR. So in reality, the basis of AI is QSAR. So we prepare models, and then with the help of models, we try to predict whether the molecule is going to be active or inactive, whether if it is active, how much will be the activity. Okay, so this was the saying by George E.P. Box that essentially all models are wrong, but some are useless. Okay, and some are very much useless. Okay, let's go ahead. Can you identify this thing? New generation specialist for you. Have you identified? Okay, so we'll go ahead. Next, please. Now, this single word cloud contains each and every information, each and every terminology, each and everything in QSAR. Everything. See, QSAR is comprising data analysis, designing, organic molecules, validation, prediction, algorithms, feature selection, toxicity, and so many things. And of this, my favorite thing is to interpret the results. Okay, let's go ahead. Okay, so we do QSAR. How we do? Once again with the help of softwares. And all these softwares are available, okay, except the 8th one, free of cost. I am not using a single rupee. I don't need any money for these things. What I need money for something else. Okay, so ACD ChemSketch is easily available. If ACD ChemSketch is not available, you can use KingDraw. Do you know what KingDraw? KingDraw is free of cost, available for your Android mobiles as well as for PCs. You can use PyMol for 3D visualization, RDKit as I said earlier. Then KingDraw is licensed, Avogadro software, OpenBabel, MMTK, PyDescriptor and PyDescriptor C star. These are the two softwares created by an Indian known as Dr. Vijay Masand. MAP एक बार और. But I'm in the lecture, I just enjoy it. Okay, I just don't want to keep it boring. Now, why this PyDescriptor is there and PyDescriptor C star means I will tell you later. Let me tell you about PADL. PADL is molecular descriptor calculator. It can calculate so many things about molecules. It can calculate almost 18,000 descriptors. Now, why PyDescriptor is better? Because the earlier version of PyDescriptor, it was able to calculate 30,000 molecular descriptors. And the recent version, which I have launched this year, PyDescriptor C star, is able to calculate more than 1 lakh molecular descriptor of each and every molecule. So we have surpassed. Usually Indians don't work, but when they work, they make a Guinness Book World Record. Okay, same thing is here. So Build QSAR is there, Veka is there, and R packages are there. Just note down the names; they are freely available. except pi descriptor and pi descriptor. I have sold it to a company. Okay. Next, please. Next. Now, something myth busting. Now, those who are working in drug discovery, they say molecular docking is theoretical work. Like this, QSAR is also theoretical work, but this is wrong. My dear friends, QSAR is not theoretical at all. Though we are doing on computer, but this doesn't mean we are doing everything hypothetically. Everything is imaginary. No, no way. You cannot do it. What we do and how it starts. First of all, we use the chemicals which are reported molecule, whose synthesis has been already accomplished, whose spectral characterization has been already done. We are using the chemicals which are really, they were synthesized in the molecule, in the laboratories. They were purified, spectral character, everything has been done already. Okay? So the beginning is with experiment. Second thing, we also collect the experimental data, especially about the bioactivity of the same molecules. This biological activity has been done in the laboratory. The wet lab laboratory experiments are over. So now we have real molecules with their real biological activity data. And what type of data we need? We need the data in numbers. Whether it is IC50, MIC50, LD50, Ki, everything. Okay? What we do, we just compare the bioactivity of one molecule with another. Some molecules are active, some are less active. What is the reason behind it? What is the feature behind it? What is the chemical structure which is causing all this? We try to find out it. Okay? And while finding out, we just look on the activity cliffs. What is activity cliffs? One molecule, earlier example where there was less nitrogen, it was less active, and after introducing single nitrogen, it was very active. Okay? 8,000, 80 nanomolar. It's a huge difference. So such molecules which have small structural difference but great variation in their activity profile, they are known as activity cliffs. Now our actual work is to find out why this is happening, and we do this with the help of QSAR. Okay, go ahead please. Next please. Okay, so we need the data. Synthesized molecule, biologically tested. Who will provide this? Someone will have to do this. So who is doing this? ChemVL database. It is free of cost available, and millions of molecules are available. Okay, so remember, everything is free of cost available for doing this job. So from ChemVL database, you can download free of cost. If you need help, you can do it on your mobiles also. In an Android mobile, you can accomplish it. Second data set where what data is available for enzyme is Brenda. A lot of information is available. Earlier, Dr. Kushewara advised you to write down the review article, but you need a lot of authority on it. You need a lot of information. Brenda can help you in this regard. So a lot of information, just like UniProt. Okay, next please. So in case of databases, once data is available, we have to accomplish QSAR in multiple 7 steps. First one is to collect the data. Second is drawing the structures. Most of the time the structures are available in Smiley's notation. We convert in Smiley's notation to 3D structures. And 3D is very important. Then molecular descriptors are calculated and their pruning is done. That means unwanted descriptors are eliminated. Then model building. Once model is built, we go for model validation, not verification. Be careful about this word, model validation. Verification means you are going for experimental program again. Whereas validation means whatever data is available, you are using it for your model validation or its authority. Okay. Last is model interpretation. It is this area where I am working, model interpretation. Because the rest of the things can be done by computer. But AI and computers cannot do interpretation. This is really required. Okay. Then and then it can be done. Next please. So the most difficult part we are now trying to touch. Single click. Difficult part, 3D optimization. Why? See, let me call one beautiful lady on Women's Day. Single click. Identify. Who is she? Smart. was expecting at least 1 week for this. Okay. So Mona Lisa is there, but she is not looking beautiful as she used to be. This is because you did the optimization not perfectly. In chemistry books, you read the word carbon skeleton. Pardeshi sir, am I correct? Carbon skeleton. It's 2D representation. You get the information, not the perfect one. One single click, please. Do it wrongly. I did it, but wrong way. What will happen? You will get more information, but still you are not the perfect. Am I correct? So what will happen? 3D optimization is not done correctly. For this, I will suggest DFT optimization. But DFT takes a lot of time. That's why we compromise certain level of accuracy by using semi-empirical methods. Semi-empirical methods like AM1 and PM3 are more suitable for organic compounds. PM6, PM7 are more suitable for inorganic compounds. Who told you? Sir, I don't know anything about PM3, etc. One more click. Do the optimization with the help of DFT and you'll give the correct answer. Now she is looking perfect women. You are still there? Okay. One more click. So when you do it correctly, you get a lot of identification, information and description of the molecule. If the photo is taken, I will ask Mona Lisa to leave the classroom. Mona Lisa, bye-bye. She will come back in the next lecture. Okay. So now let me tell you about pi descriptor. This is because my focus is on advertisement. Now this is pi descriptor and pi descriptor C star. Okay. Pi means Python based, PyMol based, and we are calculating descriptors. That's why the name pi descriptors. Okay. Now what happens? Pi descriptor is able to calculate total 30,000 molecular descriptors. Old version, but more very powerful. Okay. Now the number has increased to more than 1 lakh. Second thing, there were no chiral descriptors in pi descriptor. Now my dear friends, you know R and S nomenclature. You know R drugs and S drugs. Enantiomers are absolutely different arena of working. Capsaicin L or minus is very spicy. Okay? And the R isomer is absolutely is not going to harm anything. So one isomer, one enantiomer is active, another is inactive. Why it is so? The whole scientific community was unable to answer this. And we were the first with the help of pi descriptor to answer why this is happening. And the power. No one has ever touched the chirality of the molecules. No answer is still available. But once you use pi descriptor C star, you can identify why the R and S are different. I am now working on J descriptor, which will now handle E and Z. Soon it will be in the market. Okay. Second thing, pi descriptor also uses center of mass based descriptor, which are not available in any other software. Center of mass is calculated by pi descriptor, and new type of descriptors are there, Euclidean descriptors, not available in any other software. Then the output is very clean, CSV file, just spreadsheet like data is available. Just use it for further processing. This is one of the highlights, because so many times we have observed that a lot of softwares are unable to calculate the descriptor for all molecules, but it never fails. Then the source code is open. Remember, it is open source but not free. Some softwares are free but not open source, so you should be very careful about this thing. Now dependencies are very small. It just need a Python working condition, PyMol software, both are free, and Mol2 file format. Just that much is over. No other software is required, and it's easy to handle. Really, even a 10th failed student can use it. It's so simple, and can use multi-processing. Lastly, it is available for all the major operating systems: Windows, Linux, and iOS. So that's why pi descriptor. Let's see the magic of pi descriptor. What we have achieved so far with the help of it. Next list, please. This was the paper by mistake accepted by ACS Omega after peer review. And it is on estrogen receptor alpha binders. Now earlier in the morning, Ali sir told you about breast cancer, and some breast cancers are hormone dependent, especially estrogen. So we are also working on this. So once our paper was accepted, next please. So So this is all about the modeling. Okay, the results are very, very high. You can see R2TR. You can see R2TR 0.794. In terms of percent, I would say it is 79.4% accurate, almost 80%. Okay, and after validation, it is also still with having nearly same performance. You can see the training set was divided into test set and training set, and then the results you can see here. Almost each and every molecule is on the graph. So our model is quite linear, quite good. Okay. So on the basis of this, next please. Next, you identify these two molecules. Look at these two molecules. They have a very small difference, which even AI cannot capture. Can you recognize the difference? There is only one difference. Replacement of oxygen by. So we were trying why this is happening. Simple, one atom replacement. AI cannot capture. How we can? But we can with the help of pi distributor. What actually happened? We asked pi distributor to find out something which is very important. So it told that number of lipophilic atoms is the key to success. Oxygen being more electronegative, it is less lipophilic. Sulfur being less electronegative, it is more lipophilic. Obviously. So number of lipophilic atoms was the key to success for this. The left molecule has 22, the right one has 25. Now you will say, sir, 25? We have replaced only one atom, oxygen, but the number should increase by 1. Why it has increased by 3? The reason is that whenever oxygen is there, it is electronegative. Its electronegativity is influencing the adjacent atom. So the carbon to which it is attached is very, very positive. So it is not contributing in lipophilicity. The oxygen and carbon both are not introducing. Okay. So same thing is happening here. So this software is able to calculate if oxygen is attached to carbon, then it should not be calculated for lipophilic, and if it is removed, any other atom is there, it should be counted. So the way of counting in pi distributor is highly accurate and very sensitive, and hence it provided the answer. Now obviously you will say, sir, already log P is there, we can say, but log P is whole molecular phenomena. Okay, so in case of whole molecule, the C log P is almost comparable, 4.73 and 4.35. In fact, it is decreasing. So the activity should be different, but it should decrease. But our software, pi distributor, capture that it should have higher activity, which is in tune, okay, with the experimental data. So this is the magic of using pi distributor. One more example. Next, please. Here is one more example. Can you identify the difference? Some people are unable to identify because it is in English. What is the difference? The OH is the same on right side, but on left side, so these are positional isomers. Okay? So in case of positional isomers, and look at the sulfur, which is now present on the left molecule and absent on right side. So the descriptor calculated by pi descriptor is ring S, this one. Ring S don 6 AC. So it is saying within 6 angstrom, if donor atom is present to nearby ring sulfur, then it is going to influence the biological activity. In fact, it is going to increase it. And the same thing is absent in case of this one, and that is why it has lower biological activity. So such a minute information is captured by pi descriptor C star. One more example. Next, please. Next. Here is the lipophilicity once again. Okay. Next, please. Another paper in which we have used this pi descriptor for anti-cancer activity, aurora kinase B inhibitors. Next, please. You'll see that once again the model is very good. R2TR is coming out to be 0.815. It's close to 80. Remember, my friends, it's very tough to get R square close to 0.80. Generally, we get 0.30, 0.20 if you use other softwares. But pi descriptor will bring you to nearly a very, very good success. Next, please. Recognize the difference identified by pi descriptor. Can you? Left molecule has OH OH, which is non-lipophilic, obviously, it is going to increase the water solubility characters. On the right side, there is only one fluorine. So minute difference is captured, and that minute difference is responsible for difference in the activity. One has IC50 of 14 nanomolar, and another has 1.2 nanomolar. So this difference is captured. Next, please. One more example. And the reason is simply because the whole active site, the protein which is actually there, or kinase B, it is highly lipophilic in nature. So with the help of this, we are able to tell, because lipophilic atoms are required, the active site should be highly lipophilic in nature. And when we analyze this, the results matched perfectly. So you can imagine how much information we are getting with the help of QSAR. Generally, QSAR is unable to give you the idea about the receptor, but now we are getting it. Okay. Another example is here, where the molecule has IC50 of 316, another is 100, and we were able to capture the planar nitrogen at 4 bonds from ring nitrogen is the reason for this. Planar nitrogen and ring nitrogen, these are the two different entities, and we identified it correctly. See the difference of this. Another example, where experimentally resolved X-ray was used for this purpose. We calculated the pi descriptor for two different molecules having only the tautomeric differences. And as the tautomers are two different entities, they have different biological activities, and our software perfectly capture the reason for difference in their activity. Next. So this is the reason. So they have huge difference in there. Okay. So when there is biological activity, it is going to interact with the receptor, and why there is a change in the biological activity, with the help of QSAR we are able to capture it perfectly. Are you getting my points? Some points are coming, sir, some points are dropping down, or some are going inside but not processed perfectly because it is QSAR. Quantitative structure. Because you all are at least in PG. Anyone without PG? That means who is in UG? Is there any UG student? So you should know in QSAR. If you don't know, you can ask me, okay, after the lecture. Next, please. So there are few more examples. Now look at these three different molecules. Now a simple person will say, SAR is more than sufficient. Methoxy group is absent on the left side molecule. In middle it is present at ortho position, and in third one it is at para position. So on. But why is the difference? Is there how you can capture it? How you identify the methoxy group is responsible for this? So you need molecular descriptor calculator, and for this you need very efficient calculation. Okay. So the left molecule, which has very high activity, very good compared to other two, is found to be active because the ring carbon, you can see the ring carbon exactly at 6 bonds from oxygen atom. It should be 0. And if it is 0, then it's going to have highly active molecule. In second molecule, you will see that pi descriptor told us that there are 2 such ring carbon atoms which are exactly at 6 bonds from the oxygen atom. So this information was captured minutely by descriptor, and then third one, see, you can see the one. Okay. So whenever such an occurrence of ring carbon exactly at 6 bonds from oxygen is there, it's going to hamper the activity. And see the examples. Few more examples are there which we are able to identify these 2 molecules, which are not 2, 3. 3 molecules, their activity cliffs, they have huge difference in their activity. Once again is there. Next, please. Few more examples are there. Next, please. Now this is something which is not available in other softwares. Use of center of mass. You know, it's a unique entity of each and every molecule. But we have developed our software such that it captures how many atoms should be required within 1 angstrom, 2 angstrom, 3 angstrom, 5 angstrom, up to 9 angstrom, how many atoms are required, where the oxygen should be there, where the nitrogen should be there. Because we are calculating huge number of descriptors, more than 1 lakh, remember. So a lot of huge information is available. That's why nowadays it's possible to handle such information, crucial information which is missing right now. But now, no longer. Next, please. This is the biodescriptor C* paper which is under review right now. Okay. I will go for only Two more examples on pi descriptor having chiral activity. See, these two molecules. One is R and another is S. The left one has an activity of only 25.7 nanomolar against HDAC4, and its R analog has IC50 of 98.4 nanomolar. Why it happened? There was no answer. The huge amount of data, because almost 50% drugs are chiral in nature, we are unable to handle it. But with the introduction of this software, now we know the S isomers. See, the reason it identified is very crucial. See, it says that S isomers having hydrogen were at one bond distance, and that too partial charge on it. So the partial charge on the hydrogen atom in case of S isomer is actually influencing the biological activity. Now hydrogen is the smallest element available. Okay, so it is also identifying that the S isomer, S center, the chiral center should have hydrogen in the vicinity. Second, bulky groups are not allowed. Am I correct? And because of this interpretation, we are able to tell that S isomer is highly active, whereas in case of R isomer, as there is no S isomer, it is R itself, so the value is 0. So whenever in this series, HDAC4 series, if your S isomer and hydrogen is attached to the chiral carbon, okay, and it has very good partial charge, then it is going to be active. Remember, now we know the same chiral carbon atom, it should be S, not R. Now we know only S isomer is required. What another condition is required? The hydrogen should be there. Bulky groups are not allowed. And third, what about the charge on hydrogen? It should be positive. Am I correct? If it is negative, then it is not allowed. That means you need to attach electronegative atoms to the chiral center, and then you are able to get good activity. Otherwise, you will fail. So much of interpretation is there. Lots of interpretation is there. But one single descriptor can give you a lot of information. That's why it is said interpretation of QSR result is important. Am I running short of the time, sir? Also? Shall I continue, or aspirin should be brought in? Shall I continue? Yes. Yes, sir. Last. Okay, go ahead. I will skip this part. Okay. So last, just one more. Yes, I'll skip this one. Next. It is yes. Why I prefer QSR or molecular docking? Here is the answer. Surprisingly, docking has a success rate of only 0.01 to 0.1. Molecular docking is having success rate of 0.1 to 0.01. Sir, molecular docking has failed. No, it has passed. Passed with distinction. What are you saying, sir? It's not possible. Success rate is only 0.1 or 0.01. Still you are saying passed with distinction? Yes. This is because in molecular docking, we never go for 1 molecule or 100 molecule. We go for millions and millions of molecules. Suppose 5 crore molecules are used. Then what will be the outcome? Almost 5 lakh molecules. So you will have good molecules which could become drug. They are 5 lakh molecules. So it's a huge number. You cannot test all those 5 lakh molecules. It is giving a huge success rate. That is why it is said molecular docking, though has very low percentage of success rate, it's very, very useful. Second, in case of QSAR, the success rate is only 1% to 40%. Now, so you are beginning with experimental data, that's why you are going to get higher success rate. That's why it is said always do QSAR. Once you are doing molecular modeling, docking, etc., just finish it with QSAR. Then the chances of getting a good drug are higher. Okay, next please. So, we are nowadays conducting QSAR based virtual screening, where we just develop a model, and with the help of QSAR model we can provide the biological activity, predicted biological activity for your molecule. or ultimately you'll have to go for this. And scientists have tried this. Here is one example for 130 molecules, and finally they said that 42 molecules are going to be potential drugs. Out of 42 potential drugs, 11 were tested, and out of 11, 3 were found to be very, very active. See the success rate. 42 were said to be active. Out of 42, only 11 were tested, and out of 11, 3 are found to be very, very active. So the success rate is almost 30%. That is why I said QSR is very important. Next, another success story is about more than 3,000 molecules. Again, 176 molecules were said to be potential compound for malaria, and 42 molecules were said to be non-active. All 42 molecules were found to be non-active in reality. That is why I said QSR is going to provide you the lead or drug molecule at the earliest. Next, please. So there are some disadvantages of QSR, just like me. You can get false correlation. It could happen. False correlation. Wrong results are always there. Okay. This is because we do it incorrectly. I have written one book on this now. I'm actually writing it. How not to develop QSR. What are the different problems faced by the scientists and how to deal with. Okay. So why we fail sometimes, the reason is there. For QSR, you need large training set. Larger, the better. Sometimes people come and they ask me, sir, I have synthesized 4 molecules. Can you do QSAR? 4 molecules? QSAR is not possible. You need 20 plus molecules, at least 20 molecules. And that too, they should contain some electron donating groups, some electron withdrawing groups. Okay, so if a mixture is there, then you can get perfect results. Lastly, the bottom line. We need to do a lot because QSR is a technology and there is no exception. Some failures are always there. Lastly, we have to go for both. Structure-based drug designing, that means molecular docking and QSR hand in hand. We have to do a lot for this, for success rate. Next, last, acknowledgement to all my gurus, my parents, my family, my department, college, the organizers of the event, because generally most of them forget. That's why this slide is there. Last, for which everybody is waiting. Sorry, I took more than the given time. I apologize for this, but after a long time, I'm in front of Punekar, obviously, and that too in front of Pardesi sir. After 13 years, sir. So if you have any question, ask Somdat Chaudhary sir, because he has called me. That's very job. Yes. Any question to anyone from audiences? From non-audiences?
Yes, the session is open for question answer.
Any question you can ask. Any question from Mahila Shakti?
Online?
From male, women's day हो चुका है. You can ask.
During the presentation, you mentioned that in talking, molecular dynamics, saturations are all computer-based, and that's why psychologically they have different type of interaction.
Yes.
So, as a biopharma, information person, what are your recommendations that these type of study should be supplemented with some wet lab study that is better accepted? Because we see so many papers on computer-based modeling and simulation.
This question which is now related to current scenario also, sir. Nowadays, it is said that merely molecular docking will not give you enough privilege to publish a paper. You'll have to accomplish it with something else. Okay. So nowadays they are demanding molecular dynamic simulations. Nowadays, molecular dynamic simulations are considered as good as experimental work. but it should be around 100 nanosecond or plus, higher than that. My personal opinion that wherever the system converges, stop this thing, but generally the editors are asking for 200 or 300 nanosecond. So if you have a good machine, if you are unable to carry out experimental work in the laboratory, you can carry out molecular dynamic simulations. With the help of this, you can prove that whether your molecule is now able to sit inside the receptor for a longer time or not. If it is residing, obviously it's going to show its activity. If it is unable to sit for 100 or 200 nanosecond, it's coming out, there is no biological activity. Okay, so one thing. So this molecular docking should be accompanied with molecular dynamics. Second, regarding QSAR, the perception was that it is a theoretical one. But as I have told you, it is completely experimental based. So once you have done this perfectly and in a systematic way as per the OECD guidelines, definitely they will not ask you about wet lab experiments. Okay, do it rigorously, do it as per the guidelines. Okay, so if any question for this, you can ask. Okay, anything else?
If we do the computational studies and we get the result of compound, that is a very good activity. It is showing a very good activity in the computational approaches. But in terms of the biological activity, when we synthesize the compounds and we do not get the biological activities as predicted by the computational approaches. So can we rely on the computational approaches studies, or we do the first biological activities or go for the computational approaches?
Nice question, sir, because this is the scenario which is realistic. Let me tell you, whenever we go for QSAR, we build a model, we also go for testing the applicability domain. In which area it will work perfectly and in which area it's doubtful. So if your molecule is outside the applicability domain, it cannot work. So whenever you apply any QSAR model, just check the applicability domain. That is why in OECD guidelines it is strictly mentioned to provide the applicability domain of the model. Say for example, if my model is for antibacterial activity, and with the help of this I am trying to predict antifungal, it's outside the domain, so it is not allowed. It should be within the applicability domain, and then it can be used. Otherwise not. And for applicability domain, I will say once the model is developed, use software like QSAR. They provide applicability domain of the model. Okay, for validation purpose. Don't question आएगा. You have two questions. Two mic, two questions.
As you said now that if it is in a different domain, we can't include that study.
Yes.
So if we do a repurposing of a drug, will it be included in this study?
Yes. You can.
Okay.
Yeah, repurposing nowadays that is called as QSAR based virtual screening. So with the help of this we can. Yes.
Thank you, sir.
Professor Masand, here, I have a question.
I was waiting for this.
First of all, thanks to you for such excellent talk. Almost like you were like a teacher and we were like student. So it was a very practical way of giving the talk. Thank you for that. My question is that there is a lot of discussion is going on for substitute for the laboratory animal studies. So we have to depend on molecular docking and biosimulation instead of doing actual laboratory animal.
Yes, sir.
So what is your expert opinion about this? I would like to know.
Very tricky question, sir. Very long, but I will cut short it. See, all this technology, molecular docking, QSAR, all these are built to replace animal testing. It's as per the OECD guidelines. We should have to minimize it. And that is why, as he said, suppose we want to carry out this, so what is the alternative? So these are the alternative techniques. QSAR, docking, MD simulation. What we are doing it on simulation on computer. But as I said earlier, do it as per the guidelines of OECD, do it rigorously, very carefully, then and then the results are useful for other purpose. Otherwise, it will be useless. Nowadays, many scientists are developing molecular docking software for toxicity. Some QSR models are available for predicting the toxicity. So with the help of this, just get first-hand impression. It will be just like doing management, homework at the home, whether my molecule is going to be very toxic or not. That is why some servers are also available. Swiss ADME server, sir. Am I correct, sir? Swiss ADME server is also available there. You can get some idea whether my molecule is going to be toxic or not. Instead of going real thing, if you are already getting that my molecule is going to be so many problems, whether it is with toxicity or excretion or metabolism, then try to synthesize another molecule and then go for the actual biological testing. So we are here to minimize actual biological testing, actual animal testing. And these servers, those who are available in on the internet, they are actually built using QSR models. Okay, so these models are rigorously tested, tried over the time, and then they are available in the public domain. That's why I rely on these in silico methodologies for ADME prediction very, very high. Okay, so they have more than 80% accuracy. Pardeshi, sir.
Two questions. One is related with my field. Shall I ask that first?
Please, sir.
You have given a nice talk, first of all, and from that I can ask this question. Like, I am basically working in the field of materials, and if you want to go for the real-time application in materials, can we use this i-QSAR studies?
No, sir. It's the lacuna of this field. It is for organic molecules, that too individuals. For material science, altogether it is not applicable. It's a lacuna. Every field has some lacuna, some applicability domains. So it is not applicable. Right now, the field is going in the direction of polymers. But for materials, no development is so far. Yes, sir. Nothing is going on. In fact, for coordination compounds, the results are very poor. To be truthful, I'm not hiding anything. This technology, whether it's molecular docking or it is MD simulation or QSAR, all these are good for organic molecules, pure organic molecules, not for others.
So can we say that the metal is the culprit in your studies?
No, not at all, sir. Metals are good, sir. Biochemical studies have shown that some metal compounds are very good. But we are unable to tackle it because they have D or F orbitals. And our current computational powers are limited. So we cannot handle D and F orbital correctly. That's why the results are poor right now. Once the quantum computers are here, we will be able to do that. Then it's possible, sir. Right now we have this limitation. Not because of chemistry and other things, because of computational limitations.
Thank you. The other question was, suppose we want to find a drug and we don't have much information about any molecule. There are thousands of lakhs of molecules there. How to zero down that? So that i-QSAR studies.
Yeah, this is called a similarity searching, sir. Just upload your molecule on servers and they will provide you a perfect target for it, for which disease or for which enzyme, for which thing it can be used. So such similarity based experiments are there, and nowadays it is a hot spot. Is it because similar molecules behave similarly? That's a quotation or a basic principle behind it. But be careful about this thing because some molecules have very small difference but they have huge variation. As I yes. So similarity will give idea whether my molecule is going to be anti-cancer or anti-malarial, but within a malaria it will interact with which protein or which one, we have no idea. But similarity searches can give you a broad idea only, not the perfect one. And they will provide you ranking. Your molecule could be very good for cancer, then malaria, then for this and for this. Yes, that is possible and it's free of cost available. One server is there, binding database server. Just draw the molecule and you can get some ideas.
Thank you.
Okay, thank you, sir, Masand sir, for this interactive session. Now I would like to request Chairman of the session, Dr. Satish Pardeshi, to summarize the session.
Sir, please.
Thank you, sir.
Yeah. So, first of all, I will like to thank the organizer and Principal Chaudhary sir for giving me this opportunity to hear Professor Masand. It was a very nice talk which he has given. In fact, I am a kind of person who have seen him a long time, so right from 2012, where he was just building up his career. And now, after about a 12 years of period or so, I have seen a matured person and a nicely developed person in his field. So, a good opportunity to hear from him. And thank you for the organizer for giving me this opportunity. To summarize his talk, as my co-chairman has already stated that he is a good teacher, first of all, and from his delivery, I believe the students might have enjoyed. He started with a very basic thing of simple Google, file type, PDF, PPT and all those things. Then he very cunningly explained what is this artificial intelligence for the drug discovery, and he extended that for drug designing, delivery and development. Then he also insisted on the word artificial. Instead of artificial, he said that it should be actual intelligence, applied intelligence and adequate intelligence, which throughout his talk he has given the weightage on that, and we could visualize that how these things were applied actually in the adequate fashion. Then he went for the various programs and tried to make us comfortable about the fear about the quasar studies, which many people says that it is a domain of some specialized people. He said that the softwares which are available can be utilized. There is no much different things which we should require, and through that he opened up his topic of artificial intelligence and i-QSAR. Then he talked about his own pi descriptor and then entered into the details of pi descriptor and pi descriptor C star. And very nicely he could explain all these quasar studies, which in his talk he has said that is not theoretical, and while answering the question, he also put a press on that, like it is based on the experimental data, and if you interpret it correctly, probably you can do wonders with that. Then he also went for the structure drawing and appropriate 3D optimization, and through various good examples, common examples, he could put that point in front of the audience. Then he also made a passing remark about the organic inorganic, which I wanted to ask, and he clarified later to me that in inorganic materials probably more work has to be done, some different kind of work is required. Then he went for his own pi descriptor, in which he said that pi means Python or Pymon, and by using that he can do this pi descriptor, and it is better for predicting the structure. And he has taken the example of NLiPo, and he has explained how from 22 to 25 the things can be increased just by replacing one atom, and very nicely the chemistry can be blended with the quasar studies and the pharmaceutical studies which we can talk about. And he was talking about the ring carbon and the 6 bond which hamper the activity and how nicely it can be predicted. That was also explained nicely. And finally he went for the success story of and the comparison between the molecular docking and quasar. And then he said that how quasar is better in terms of the molecules which are heated, and through that the success story can be talked about. So to summarize, it was a very good talk, and I personally gained a lot from that. Even though I am a material chemist, probably in future I can think to collaborate with him and have some sort of better chemistry done through that.
It will be honor for us, sir.
Yeah. Thank you. I will request our co-chairman also, if at all he want to pass some remarks.
Already explained my chairman sir that talk was very nice, and you have spoken about all the advantages, but at the same time you didn't forget to speak about disadvantages also. That is greatness of your talk, and it is a greatness of you. So overall, I can summarize excellent talk, very useful, and I am also thinking similar way that how I can collaborate with you. So
You are most welcome, sir.
yeah. So thank you very much.
Thank you, Abhinav. Thank you, sir. Now I request Chairman Dr. Satish Pardeshi to felicitate Speaker of the session, Dr. Vijay Masand, with memento, certificate and floral bouquet.
An honor, sir. Sir, happy. Just.
Please give a big round of applause. I request Dr. P.D. Chaudhary sir to join us on the stage. Now I request Co-Chairman Dr. Sachin Agawne sir to felicitate Chairman of the session, Dr. Satish Pardeshi, with memento, certificate and floral bouquet. Please give a big round of applause. Now I request Dr. Somdatta Chaudhary, Organizing Secretary and Computational Study Expert from our institute, to felicitate Co-Chairman of the session, Dr. Sachin Agawne, with memento, certificate and floral bouquet. I request Chaudhary sir to escort all the dignitaries of the dais. I hereby declare that the scientific sessions for today are over. Offline poster presentation will start immediately after the lunch. All the participants are informed to paste their posters in the conference hall on first floor as per their respective abstract IDs mentioned on the panels. Sellotape scissors will be provided over there. Our scientific team and volunteers will assist you for the same. Offline oral presentations will be continued in this auditorium only. So all the participants of oral presentation are informed to regather in auditorium after lunch at 2 p.m. Simultaneously, online oral and poster presentation will be conducted through Google Meet, and instructions for the same will be shared on respective WhatsApp group. Once online and offline scientific presentations are over today, I request all the delegates to be present here and regather in auditorium after presentations, and online delegates can join through this same Zoom link for cultural program specially organized for this event. I am sure you all will definitely enjoy it. I request everyone to proceed for lunch on ground floor. Thank you.